Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. And today's video is about complete SAS macro tutorial, and this is for beginners to advanced SAS programmers, and it is a 6 hours long video. And now I would like to say one thing in here. These are 10 videos which I have earlier made and clubbed into one. And I have done this just to make things easy for you. And let's quickly look into the topics we are going to cover. Initially, I will be having introduction, then macro variables, and then I will also be talking about macro and macro parameters, and then conditional and iterative macro statements, followed by creating macro variables in Proc SQL and how to use them, followed by call SYMPUT, and then macro functions, and also about macro libraries, call execute, and scope of macro variables. And now I would like to advise one thing. When you want to watch this video, please do watch one video after another in the order I have mentioned in here. The reason being, one video or one topic builds upon the knowledge from other topic. So always go in particular order if you are starting, or if you know or already have some knowledge, you can pick up any topic and then learn. But if you're starting, please go in the order. And I will also provide time series of which part starts at what time and ends what time in the description. Today we are going to see the part 1 of SAS macro series, and this is introduction. And here I would like to tell a couple of things before going into the topic itself. Here I will be presenting a lot of information. Most of the information which I am trying to present here is what I will be covering in the future classes. So this will be a very high level class wherein I will be introducing a lot of concepts, and I want to show you here what macro can do and what is all about macro. But the details of all these things we are going to understand in the future classes only. So to sum it up, this class is all about giving a high level information about SAS macros. Now let us try to understand what is the main goal of macro. The main goal of SAS macro is to generate text. It works more as a text generator or a source code generator. Now we will try to understand this with examples. So in the text generation, we are going to discuss two kinds. Initially, I will discuss simple text generation like text generation for dataset names or variables, or how to generate lots and lots of code using SAS macro. Now, as I said to you, this is a very high level class, and in the future I will be going into details of all of this. Now let's try to understand the simple text generator. And here I'm using this with the help of %let statement, wherein I will be showing how to generate text, especially in the case of simple scenario. Now here I have a %let statement, and here I am saying %let dsn equal to SAS help.class. Here we are creating a macro variable, and a macro variable has the value of SAS help.class. So what do you need to understand here is whatever we are storing in the macro variable itself is simple and plain text. And here, once we have defined our macro variable, I can access this macro variable in the below proc. So what is happening in here is I'm referencing this macro variable by using ampersand dsn. So when ampersand dsn is used, what is happening is it is going to generate this SAS help.class here, and here. So if you can see, In this example, what we are doing here is generating simple text for our procs. Now more on %let statements and others in separate classes. I will be having individual class for %let statement. Now let us quickly run this code. Here I have added one more thing in here, that is option symbol gen. Symbol gen is one of SAS macro debugging option wherein it gives the value of macro variable itself, or it gives how this value is resolved or what is the value it is resolved into. Now let us quickly run this piece of code and see what is happening in the log and also what is happening in the result. In the result, we can see that it has done proc print, proc mean and proc freak. And let's also look into the log. In the log, it says that our macro variable ampersand dsn is resolved to SAS help.class. This is what I was talking about. That is, this dsn is resolved into a text, and this text is used here for our proc print. Now this proc print becomes proc print data equal to SAS help.class run. In the same fashion, for other two procs also, this dsn, or rather ampersand dsn, is resolved into SAS help.class. This is, in a way, we are providing text to these procs with the help of our macro variable which we have created in here. Now let us look into our next example. Here we are going to generate code, not simple text like what I have shown you earlier. To understand this, let us look into an example here. Here I have a dataset have, and I want to append have to dataset want. I can simply use proc append, but I want to do it 100 times, which means I want to do proc append base equal to want, data equal to have, run. I want to write 100 times so that the data in the have appends in want for 100 times. So if I have to do this without the help of macro programming language, what I need to really do is I need to write this step 100 times. Instead of that, what I can do is I can create a simple macro and then execute that macro, which will create all of these statements 100 times. So in a way, we are generating code 100 times. I again know that I have not taught you anything about creating and executing macro, but we will be seeing that in our future classes. Now let us see this in real time, how we are going to do it. Now here I have the same data set have, and I am using here a macro which I am calling it as ABC, and then I am also executing this macro by using %abc. You need not know everything, or you need not understand everything in here, but what I want you to understand here is how macro programming language is helping us to generate the text without we typing it. Now I also have options mprint in here. What mprint does is it gives the SAS statements which are created in SAS macro. SAS macro is nothing but whatever we are creating in between this macro and ment. Now let us quickly run this whole of this code and then look into our log, and then we will understand it much better. Now once I have run this code, and let's look into our log. If you look into our log and let's go very up, we can see that there is a lot of proc append statements here. See here, there is one proc append statement, there is two, there are close to 100 proc append statements. So if you think closely, without typing this proc append base equal to want, data equal to have, run, the macro itself is creating these statements for us. 1 time, 2 time and 100 times. And if you look into the data of the want will have close to 400 records because it has appended so many times. 4 records, each one of them have, and then I have appended it 100 times. Here another important thing I want you to remember is I have made a video on this, and link for the same I will give in the description below. It goes in little bit more detail about this. But with these two examples, what I want you to understand here is macro programming language is more of a text generator, and I want you to think in the terms that whenever you want to provide some text or whenever you want to generate some code, you always think about macro programming language. Now that we have looked into how macro programming language works as a text generator, now let us quickly look into how the macro program is used in the real time. These are some examples. I'm not going to go in detail into any of this. I will touch base it at a very high level. Again, we are going to come back to all of this in the future sessions or classes. Now, the macro programming language is helpful in 4 points here. I don't want to read out, but let's see it in here. So, macro programming language, we can create a macro variable in some step. That is, here I have a Proc SQL step. And these macro variables which I am creating in here, I can use in some other step. So, macro programming language is very helpful if you want to create macro variables in some step or somewhere and use it somewhere else. And then next one is, as I've already shown you, you can repeatedly execute any procedure or anything. Here we have repeatedly executed this code 100 times. And the next example, let's look into, again, I'm not going to go in the details of this one. Here again we have a macro. And here what we are doing is, depending upon the parameter we pass here, we will either proc print or we will either do this data step. Whatever the value we pass here, if we are going to pass happy here, if happy equal to happy, then this is going to execute. So again, we are creating a macro and we are executing a macro, but the control we have is if we want to do this step or we want to do this step, we can conditionally execute it. This %if, %then, %do look little bit complex. So I don't want to go in detail in here, but we will be touch basing that in the future classes. But what I want you to know is a macro programming language gives you a control to conditionally execute a data step or a proc step depending upon the value we pass in here. Now let us quickly run the code what I have shown you earlier. But here also I have options mprint and mlogic. I have spoken about mprint earlier. Mprint, mlogic are SAS macro options which we generally use to debug the code. Mlogic tells about how a macro is executed. Now let us quickly compile our macro and also let's run the options too. The compiling of macro means we are running the code from %macro to %ment, which is our macro. And once we have compiled, I can pass the parameter I want to pass. That is, here I am passing val equal to happy. That means I am giving this macro variable value val as happy. And then let's quickly run that. Once we run this code, you can see that SAS help class has been printed. And let's quickly look into the log also. Here the log, you can see that proc print data equal to SAS help.class run has been printed, and you can see that the condition happy equal to ampersand val is true because we have passed happy as the value. Now, if I run val equal to sad, that is my macro variable or my macro parameter value as sad, then you are going to see that we are creating a data set. And let's quickly look into the log. So in the log you see that the happy equal to ampersand val condition is false. That is what our mlogic tells us. But the most importantly, you can see that this piece of code is executed. So what I want to tell from whole of this thing is, depending upon the value we pass, we can have control to do a proc print or to create a data set. This kind of thing is generally very difficult to handle without having any macro. Again, I want you to focus on one important thing. That is, whenever we are running this whole of this code, you need to remember that we are generating this text or this text. After the code is generated, it is executed with the SAS compiler. One of the most powerful aspects of SAS macro programming language is how flexible it makes the code and also how generalized it makes the code. Let me explain you through an example. For example, here I have three procedures which I want to execute, that is proc print, proc means and proc freak. And I want to do that on a same data set, that is SAS help.class. So what I could do simply is I can write %let dsn equal to SAS help.class and I can reference them at three places like this. What is the advantage of writing in this fashion? For example, tomorrow you are not interested in SAS help.class but you want to do SAS help.cars. So what you can simply do is you can simply write %let dsn equal to SAS help.cars. As the macro variable name dsn is same, it will pick up now SAS help.cars instead of SAS help.class. Now let us look into the code we have just now discussed. Here I have my %let statement here wherein I am saying %let dsn equal to SAS help.class, and then I have my proc print, proc means and proc freak. All of them have data is equal to ampersand dsn. Now let us quickly run this piece of code, and after running the code, let's quickly look into the results also. In the results you can see that we have proc printed SAS help.class and we have means related to SAS help.class. And here now I want to change this class to cars. So simply what I can do is can change the SAS help.class to SAS help.cars. It is super simple. I did not have to change at three places, but I have to change in one place. And once I run this code, it will print and it will do everything related to SAS help.cars. Now, the data set of SAS help.cars is much bigger, so it took some time. Now you can see that we have different proc print and different proc means and others. So if you see, there is a lot of different information here. The main emphasis point I want to say in here is, for example, if I had some 20 or 30 statements, which are most often the cases in the real world, I have to change at one place and everything follows through. This gives a tremendous amount of flexibility. And whenever you have a scenario when you're using the same thing at multiple places, always use a macro variable so that if you want to make any changes in the future, it will be smooth and you don't have to repeatedly write the code. You just need to change at one place and everything flows through. I just came up with some applications. There could be many more applications. Now that we have looked into what is a SAS macro and what are some common applications, now let us look into how SAS macro works. So whenever we have SAS macro related code, that is whenever we have percent or ampersand symbol, which are known as macro triggers, they work first and then the remaining code which is a data step code or maybe Proc SQL code, it runs later. So to understand this, let us try to understand it little bit slowly. Whenever we have macro references along with the code, we need to understand that macro references are resolved first. And this is because of design, because we want macro processor to generate code for our data steps or other procs. This is a very important thing to understand. And let's try to understand this by looking into next slide. Here again we have %let dsn equal to SAS help.class, proc print data equal to ampersand dsn run. When we run %let dsn equal to SAS help.class, we are going to create a macro variable. And we are going to reference in this proc print. Now we need to understand one thing in here. When we run this proc print, the proc print itself is not going to run immediately, but first this ampersand dsn resolves to SAS help.class. Something like this: proc print data equal to SAS help.class run. After this ampersand dsn is resolved into SAS help.class, then only proc print runs. And as I said to you earlier, anything with the symbol of percent and ampersand followed by a non-blank is known as macro triggers. When SAS macro processor looks into this ampersand or percent symbol with a non-blank character, it will execute immediately. And this is very important to know. And now let us try to understand whole of this in more detail and in a form of a visual. Whenever we run our code, for example, in here we have our code like %let macvar equal to SAS help.class, data class set ampersand macvar run. We need to understand that the code immediately goes into memory, and this is known as input stack. Once the code is in input stack, what happens is there is a word scanner which looks into each of these words and will try to understand what kind of words they are. Or rather we could say it looks into them as tokens, whether this is a literal token or whether it is a number token or whether it is a name token and whether it is a special token. Percent symbol and ampersand symbol are special tokens. Whenever this percent symbol or ampersand symbol are seen by macro processor, it immediately executes them. In here what is happening is, as soon as it sees the %let statement, what happens is this macro processor looks into them and then it creates this macro variable and keeps into a symbol table. More on the symbol table as we move to the future classes. And then this whole of this code goes into a compiler. And once this ampersand macvar is resolved into SAS help.class, which gets its value from the symbol table, then the compiler will compile this data step and the code execution happens. I have not really gone to the details of how tokenization happens. That is how each word is checked line by line, word by word, and then how they are analyzed and all those things. But the important point here, what I wanted to say was, there is a macro processor after this tokenization wherein it looks into macro triggers and will try to resolve or work on them immediately even before the code is compiled. Now I would like to focus or explain how I am going to teach SAS macro programming language. I will be discussing or I will be focusing on three main concepts, and these three concepts are very important to know to work in the real time. The first one is simple substitution. Second one is how to create simple macros, and the third one is dynamic programming, wherein you are not going to do any hard coding or you are not going to pass parameters, but you are going to write programs which are data driven. And here we will be using call SYMPUT or into clause followed by usage of control table and call execute. Even though I have mentioned here three concepts, we will be covering various topics like %if then statement, SAS macro symbol table, SAS macro function, SAS macro libraries, and others. Now let's look into each one of them very briefly. Simple substitution looks something like this, wherein we will be creating macro variable and we will be referencing those macro variable in our programs. And also the macro program creation is also something like wherein we start with the macro and wherein we end with mend, and we have lot of program in between, and then we are going to execute this macro. And the third and the final one is dynamic programming. Here, to understand this, let me explain you with a simple example. Now I want to proc print all the datasets of SAS help wherein the dataset name starts with C. Instead of passing something like this wherein I can pass dsn equal to SAS help.class and something like that, I want to write a program wherein I really don't have to hard code anything, but I can create a macro variable somewhere in here like as shown in here, and then I can do a proc print. This kind of program is not dependent on any human intervention or hard coding, but rather it depends upon the code the way you have written it, which means you are handling everything in a very dynamic way and very data driven way. Now it's time to conclude our introduction. In this introduction, I have covered quite a few topics. The first one is I try to explain what a macro facility does. And what a macro facility does is it generates text. It should be text generation, not text substitution. And it can generate simple text or lot of text. And macro programming language has lot of applications like passing values between one step to another, running multiple times same proc or data step, or conditionally executing proc or data step, and also it helps us to make a flexible code. And now let's try to look into another important point which we also discussed, how macro facility works. The most important here is macro triggers, which are percent and ampersand followed by a non-blank character, work earlier than our SAS programs, which could be data step or Proc SQL or anything else, are compiled later. And our learning strategy will be simple. It will start with simple substitution followed by writing macro programs and finally dynamic programming. That's all for this topic. And today's topic is SAS Macro Series Part 2. And in this, we are going to talk about macro variables and %let statement. There are many ways to create SAS macro variables, and one of them is %let statement. And here, I want you to understand few other things about macro variables. Macro variable, the naming convention is very similar to SAS data step or Proc SQL variables. And those rules are the variable name or macro variable name should not be greater than 32 characters. And also the variable name should start either with underscore or with a character. And also we can have only underscore, character or number as a part of our macro variable. Once we have looked into what are the characteristics a macro variable name should have, now let us also try to understand here the %let statement very quickly. Here I am defining %let dsn equal to SAS help.class. Here dsn is our SAS macro variable name. and here SAS help.class is its value. And I want you to also remember the value of the macro variable should not be more than 65534 bytes. This is not a very important thing to remember, but just in case. And also this value is a text. Once we have created our macro variable by running this particular statement, we can reference this macro variable by using ampersand DSN. Whenever we are doing ampersand and the name of the macro variable, this is known as referencing the macro variable. Now here we have proc print data equal to ampersand DSN run. This macro variable value resolves once we run this proc print, and then the proc print itself will work. Now I want you to understand how the code works. When we run proc print data is equal to ampersand DSN semicolon run semicolon, we need to understand that first the macro variable resolves and it becomes SAS help.class, and then proc print works. Here I want to remind you one point which we have discussed in the earlier class. That is, ampersand and percent are macro triggers and they execute first even before any other code is compiled and executed. So always macro variable resolves first and then this piece of code runs next. Now let us look into another aspect, that is percent put statement. Percent put statement is very similar to put statement. Put statement deals with the text and variables of data step, whereas in the case of percent put, it takes care of text and also macro variables. Now, when we say percent let dsn equal to SAS help.class semicolon, and when we run this code, we are creating a macro variable and we are referencing this macro variable by using a percent put statement. As and when we use put or percent put, we have to remember that the main concept there is to put the values in the log. But percent put deals with macro variables rather than variables. Now, when we run this percent put statement, we are going to see this in the log. That is, we are going to see that this ampersand DSN has resolved in SAS help.class. Now that we have understood percent put, now let us quickly focus on what is the difference between put and percent put statement. Here I am having a data step data underscore null underscore, and I am having a put statement and I have some text. Whereas in the case of percent put, I have another text. If you see here, put statement comes before percent put. When we run this piece of code or when we run this data step, what you will see is, you will see this percent put executing first even before put. And this is pretty clear from what we have discussed in the last class and just a slide before. That is, percent and ampersand are macro triggers and they always resolve first than anything else. So here, if you run this code, this is what we see in the log. We see this is for percent put statement. We see this resolving first and then this put statement value resolving next. So let us try to understand how this whole thing works. When we try to compile this code, what happens is, even before this data step is compiled, this percent put statement runs first and it gives us this value. Then this data step compiles and then this put statement gives us the result as you can see in here. If you see here, the put statement value, this is for put statement, comes after the data step is complete, which means after this code is compiled and executed. And percent put statement is very useful, especially to debug. Now let us look into another aspect of macro variable resolution. Here I have pretty much the same code, but here we are creating a new variable percent let mac var equal to m. And here I am doing proc print data equal to ampersand dsn semicolon, where sex equal to double quotes ampersand mac var double quotes run. Here it is going to resolve into m, and then we are going to get the proc print where sex equal to m. Here the important point to remember is here we have double quotes. And macro variable, when kept in the quotes, it only resolves when it is in double quotes, but not when in the single quotes. When we try to resolve the macro variable in the single quotes, it just simply picks up as a variable value but not as a macro variable. So whenever we try to put ampersand in a single quote, it will not look for macro variable. Now let's also try to understand by running the code. Here I have my %2 let statements, and here I have proc print where I say where sex equal to double quotes ampersand mac var double quotes close semicolon. Here another important point to remember is I have option symbol gen. Option symbol gen helps us to understand what the macro variable has resolved into. Now once I run this piece of code, it's going to proc print SAS help.class where sex equal to m. And also if you look into the log, it's going to tell us that macro variable mac var has resolved to m, and then it has printed what we want to print. We can also see that from the note, wherein we can see where sex equal to m. That is our mac var has resolved into m. Now let's try to run the same thing but in single quotes and see what happens. And here we don't see anything in the results here. But let's also have a quick look in the log. In the log, we see that ampersand dsn as resolves to sashhelp.class, but there is nothing related to ampersand macvar, which is in single quotes. What does this mean? This means now this value appears more as a variable value rather than a macro variable. So it is no longer going to look into macro variable and then going to pick the value from there. Here also it says that no observations were selected because there is no data with ampersand macvar in sashhelp.class. So it is very important to put double quotes whenever you want to put a quote and resolve the macro variable. Now I would like to emphasize on another important concept, that is macro variable is a text. I might have repeated this so many times, but this is an important point to understand. Here, if you look into previously, what we were doing, we were trying to get %let mac var equal to m. And then what we are trying to do is ampersand mac var, and we are trying to put double quotes around it. But if you want to have the same thing, we really don't have to have double quotes and everything in here. What we can directly do is we can define %let new mac var equal to m double quotes, and we can do the same proc print. What is happening in here is it finally resolves to where sex equal to double quote m here. So what I want to make you understand is either this way where you create a macro variable and put it in double quotes will work, or directly put a double quotes here and use it in here. Now I also have %put statement here, so I can put the value into the log. And here I have also written additional text so that my %put is more cleaner. Now let us try to understand these by running in our SAS Studio also. Here I have my %let statement, that is %let new mac var equal to double quotes m. And I have also have my %put statement where I am saying value of new mac var equal is ampersand new mac var. So when I run this, it is going to put the value of m with the double quotes in log. Run. Now let us run the proc print too. In the proc print, you can see in the log that new macvar resolves to double quotes m. So whenever you want to create a macro variable, think strategically, think in the terms of that it is a text and first it resolves and it gives the value you want. So you can put the double quotes or whatever it is in your macro variable itself. I want to continue couple of more slides and explain you in more detail that macro variable is text. So one important point when you talk about macro variable as text, that we are indirectly telling that it's neither a character nor a number, it's just a plain text. So there is no concept of null. When we talk about a character variable or a numeric variable, we have a way to represent null or missing value. But in the case of macro variable, text is there or text is not there. For example, here I have %let hello equal to semicolon. I don't have any text. This is what it does not have a value means. So it is not like a null or an unknown value. So if we want to use this ampersand hello somewhere like this, it's not going to resolve into any text and it is going to proc print without any problems. In here I have proc print data equal to ampersand macvar1 which resolves into SAS help.class and ampersand hello, it resolves into no text, so it just stays as sasf.cars and this proc print will run fine. Same is the case with proc means here where I have sasf.class and ampersand hello. Ampersand hello does not have any text, so it stays as sashelp.class itself. This is a very important point to remember. Now let us take it further. I have some examples of %let statements and also have my %puts in here. One another important point to remember from %let statement is whenever you have space in front of text or after the text, it is not stored in your macro variable. And also I have three other macro variables wherein I am creating with some other thing than what we generally think of text. I have quotes here, I have double quotes here, I am having some symbols here. The important point to remember is whatever you have will be stored as such. It's not going to resolve into something else. It is a plain text and it comes out as text when you try to resolve in it. Another important point to remember is the space in front and the back of the text is not stored, especially when you are creating macro variables using %let statement. Now let us try this in our SAS Studio very quickly. Here I have the same thing what I have shown you in the slide, and here I am trying to do the %let statements followed by my %put, and also I have the pipe in here. The advantage of using pipe like this, if there is some space in front of it, it will show up. Now let us quickly run all of this and see what are our results. Now here if you can see, our results are value of A is high. Even though we have space, that space was removed. And here we had a space at the back. For C we had a space in the front and back. All the spaces have been removed. That is true with %let statements. Whenever we create with the %let statements, we cannot store the space before and after the text. And if you see here, the macro variables wherein we have quotes, it resolves as it is, as the text you can see in here, as the text you can see in here. Now let us look into another concept, that is overwriting macro variable values. And we will try to understand this through an example. Here I am defining macro variable %let dsn equal to sashelp.cars, and I am referencing this macro variable in my proc print in here. As my macro variable value is sashelp.cars, the proc print will print sashelp.cars dataset. Now that we have created a macro variable does not mean that the macro variable is there for the whole SAS session. We can always overwrite it. Overwriting the macro variable is again very simple. All we need to do is %let dsn equal to sashelp.class semicolon run. That is, we need to run another %let statement wherein we can change our value, and here we have changed the value to sashelp.class. And now when we proc print, the proc print will print the data set related to sashelp.class, because now our macro variable value is sashelp.class. So overwriting macro variable values is super simple. All you need to run is run again the %let statement followed by proc print or whatever you want to do by referencing that macro variable. Now, we should also look into another important aspect. That is, there are some macro variables which belong to SAS session and which are created by SAS, which we can't overwrite. Those macro variables are known as automatic macro variables, and we cannot override them. To look into what are those automatic macro variables which are created in the beginning of the session, all we need to do is we need to write %put underscore automatic underscore semicolon, and when we run this we will find the automatic macro variables. There are many automatic macro variables which are created in SAS session, but here I have pasted few of them. If you look in here, sysday is another macro variable which is the value of Friday. I ran this %put underscore automatic underscore on a Friday, so my sysday has a value of Friday. If I try to do something like %let sysday equal to Sunday semicolon, it is going to give me an error and it will say that attempt to assign a value to read-only symbolic variable. What does that mean? Symbolic variable means macro variable. Whenever it says read only means we have only the way to read from that value but not write to that value. Now let us dive into another topic, that is how to add text to the macro variable. I have made a very detailed video on this topic and I will give the link for the same in the description. Now let's get into the topic itself. Here I am defining my macro variable %let c equal to high. This macro variable I can reference as $c or $c dot. Both of them are going to give me the same result of high. Now if we run this code, we are going to see the following result in our log. If you see, the value of c without dot is high, value of c with dot is high. So both of these statements just resolve to high. I mean to say the macro variable resolve here into high. So the dot in the macro variable, what it tells is, it tells that this particular macro variable has ended and anything after that dot is not part of that macro variable. This is very important and very useful, especially when you add text. Now let us add some text to the macro variable and see what happens. Now here my macro variable I have defined as %let macvar equal to Smith. I can add text in front of the macro variable. In this case, I have done %put name is &macvar. Here, what happens is, as this &macvar, ampersand is a macro trigger, this &macvar resolves first, and as name is in front, this becomes name is Smith. So this is pretty straightforward scenario. But what happens if we add text at the back of the variable? That is, if I add &macvar, after that if I want to add John, to it, what will happen is it will think that the macro variable you want to give is ampersand macvar John, and we will get a warning saying that apparent symbolic reference macvar John not resolved. So it is very important to do something wherein we are saying that this macro variable is ended and everything afterwards is text. Now let us see how we can do that. Doing that is super simple. All we need to do is we need to add a dot, and then this resolves to Smith John now. So what is happening in here, ampersand macvar dot first resolves into Smith, and John is a text and it becomes Smith John. And this is very important to understand. Whenever we want to add text to the back of a macro variable, we always need to add dot, and this dot is the part of the macro variable and it resolves. If we are not going to do this, we will be having the problem that the particular macro variable does not exist. And if we want to have something like Smith.John, we need to add two dots here. That is %put ampersand macvar dot John. So what is happening in here? First ampersand macvar dot resolves into Smith. The next dot is a text. You can see here, and John. And this becomes Smith.John. Now let us look into the last topic, that is direct and indirect macro variable reference. Till now what I have discussed is direct reference. That is where we are using single ampersand. For example, here I am defining my macro variable %let name1 equal to hello, and I am trying to reference this macro variable using a single ampersand. That is %put value is ampersand name1. This is a single ampersand and this resolves into hello. This is a pretty straightforward scenario. Now let us look into an indirect macro variable reference. This is really very helpful, and the reason for using this kind of thing we will discuss in the future classes, but for now let's try to understand what is indirect macro variable reference. For understanding indirect macro variable reference, let us try to use the same example. That is, we want to use %let name1 equal to hello. Here I have another macro variable %let I equal to 1. The goal now is to use name, which is a part of macro variable name here, and ampersand I, and we want to resolve hello, which means a part of the macro variable name here and this macro variable to resolve into this particular value hello here. If I do %put ampersand name ampersand I, what happens is, as we have not defined macro variable name, we are going to get a warning saying that apparent symbolic reference name not resolved. But ampersand I is there, ampersand I resolves to 1. So finally we are not able to resolve back to hello. How we can do this? We can do this with the help of indirect macro variable reference, which is by using multiple ampersand. Again, instead of using single ampersand name ampersand I, if you use double ampersand name ampersand I, this resolves to hello. Now let us try to understand how this works. Macro variable reference starts from left to right. So what happens in here is two ampersands resolve into one ampersand first, and this ampersand I resolves into 1. Now it will again go into another pass wherein this ampersand name 1 resolves into hello. So to sum it up, in the first pass, ampersand name ampersand I became ampersand name 1. In the second pass, ampersand name 1 resolved to hello. Now let us try to understand this more deeply by using symbol gen. Option symbol gen helps us to know how macro variables are resolved. Again, here I am using percent put ampersand 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 I, but I have the option symbol gen. So option symbol gen tells us how the whole thing resolves. Symbol gen says that ampersand ampersand resolves to ampersand. Ampersand I is resolved to 1. And now we are left with ampersand name 1, that is macro variable name 1. Macro variable name 1 value is hello. Here the important thing is to understand that if we have used a single ampersand, it would have resolved immediately. Because we have used two ampersand, what has happened is the macro variable has not resolved immediately, but it resolved when we wanted it to resolve. So these two ampersand became one ampersand and this became ampersand name 1 and we were able to get hello. I have covered a lot of topics for macro variables, but not all the topics related to macro variables, and some of them we will be discussing in the future classes too. That's all for this topic. Today we are going to look into SAS Macro series part 3, wherein we are going to discuss about macro and macro parameters. Let us quickly look into what is a SAS macro and what is compilation and execution of SAS macro. Here SAS macro can be defined by writing %macro followed by name of the macro. Name of the macro should follow the same rules which we follow for variable name. And then we have some code in here. For our context here, this code is not very important for now. And this macro ends by %ment and we have macro name. We don't have to give this name, but for more clarity, we can have macro name also followed by %ment. So this is a simple macro. And once we run this piece of code, it is known as compiling a macro. And we can execute this macro by doing % and the macro name. Now I'm going into lot of details with what is this compilation means, what happens at compilation, what happens at execution. Before doing all those things, I would like to explain briefly what are the advantages of SAS macro when compared to simple %let statements. %let statements is designed to replace simple text, whereas in the case of macro, you can create or generate a lot of text, and also you can automate a lot of processes by embedding a lot of logic in the macro. These kind of macros we will be seeing in the future classes, but now I just want you to understand this one difference before going into the details. Now let us try to understand what happens during compilation of macro. During compilation of macro, only macro related syntax is checked. And if there is a syntax error, we will see that a message saying that there is an error and a dummy macro has been created in our log. And when we say dummy macro means the macro which we want to create has not been created. And couple of things happen during compilation of a macro, and this are important to know. First, macro will be stored in a macro catalog and macro statements are compiled and stored while everything else is treated as text. And now let us try to look into our macro once again. Here only where we have %macro and %ment, this syntax is only checked, and proc print, which is not related to macro but it is a simple procedure, will be treated as text. Now let us try to understand this in a more of pictorial form, and this is something which I have shown you before in the very first class. That is what happens when we run the code, what happens and how macro processor deals with whole of these things. Let's try to understand the same, or let's try to use the same and try to understand our SAS macro compilation. Whenever we run the code will be in input stack, that is in memory. And word scanner looks into word by word and understands whether it is a literal, number, name, or it is a special token. And once it understands that this is a special token and also it has a percent and it has a percent here, macro processor understands these percent symbols. As I have told you earlier, percent and ampersand are known as macro triggers, and macro processor understands this, and then once it looks into macro and percent meant, during compilation what it does is it stores the macro in macro catalog. Now how it is stored and what are the some more details of this catalog, let me show you in here. Here the catalog is in work area and the name of the catalog is SAS MAC1, and this is for SAS Studio. For others, this catalog name could be different and it could be something like SAS MACR. But the important thing to understand is whenever we run our macro or compile our macro, it will be stored in one of the catalog in here. Now I have used proc catalog and set catalog equal to work.sasmac1 contents run and quit. This will tell me what are the macros that are stored in my catalog, that is SAS MAC1. It tells me that there are a lot of macros, but I am more interested to show you there is a test macro which we have created in here, and then you can see that when that macro was created and whether it was modified or not. So the important point to know is your macro is compiled and it is stored in a particular catalog. And now I want to go into further more details about the compilation itself. Here again I have my percent macro and percent meant, but after this macro I do not have a semicolon. After the macro name, it was supposed to have a semicolon. I did not write the semicolon for the purpose of illustrating that when you don't have a semicolon or macro syntax related issue, we are going to see an error saying that expected semicolon not found, macro will not be compiled. And also we will have an error saying that a dummy macro will be compiled. Now let us try to understand the same thing pictorially. Again, the code goes into the input stack and the word scanner does the tokenization. Here the macro processor understands that there is a syntax error and it will no longer store the macro in macro catalog. And if we run proc catalog and try to see whether this macro has been stored in the catalog, we will not be able to see that the test one has been stored in the macro catalog. Now let us quickly go into little bit more deeper and try to understand more about the compilation. Here everything is same, the macro name is test2 here, and one difference in here what I have done is I have given syntax error for this proc print. As I told you earlier, anything which is in the macro, if it is not related to macro statements, it will be treated as text. So it will never look into the syntax error of this proc print. I wanted to say that this proc print is missing a semicolon in here, but it is never looked into because this whole thing is treated as text, and once we compile this macro and we run proc catalog, we can see that this particular macro has been compiled and stored. Now let us look into macro execution. A macro execution can be done by writing percent followed by a macro name. We don't need any semicolon for this. And when we run this piece of code, that is percent macro name, what happens is it comes into input stack. And then word scanner looks into this. As we have percent sign followed by macro name, percent sign is a special token and it is also a macro trigger. So macro processor understands this, and what it does after it sees percent followed by macro name, it opens the macro catalog and reads this macro. And then what it does is it finds the text in here and it puts into the input stack, and then again the word scanner reads this, and there is nothing here for microprocessor, so it goes into the compiler and proc print data equal to SAS.class run will run. So here I want to mention couple of things. Whenever we are executing a macro, generally it is a repetitive process. Here what happens is, first it opens the macro catalog and it reads this macro, and then it puts whatever it is there in here into the input stack, and again it follows the same process. Here we are talking about a simple macro, but what happens if we have macro parameters and macro statements? We will look into that later. Now that we have looked into SAS macros without any parameters, now let's try to understand SAS macro parameters. SAS macro parameters are nothing different. They are also SAS macro variables. And SAS macro parameters, what they do is they make the SAS macro more dynamic and useful. Two of the important parameters which we are going to discuss are positional and keyword parameters. These macro variables which are created as a part of parameters are known as local macro variables. Local macro variable means those macro variables which are available to that particular macro which creates it. Now let's try to understand these positional parameters and keyword parameters with an example. Here again I have my macro and mend, and after my macro I have a macro name, and here I have given it as more functionality as its name. And in the bracket or parenthesis, you can see I have three parameters. The first one is known as DSN, and then I have a comma, start, comma, and then end. Means here I have three macro variables. And the first one is DSN, second one is start, and third one is end. So here, when we are saying three parameters here, means we are creating three macro variables. And these three macro variables I am using in here, and in here. And in here I have proc print data equal to ampersand DSN, first ops equal to ampersand start, ops equal to ampersand end, and then I am closing my parenthesis, semicolon, run, and then percent mend. Means I am finishing up my macro in here. Here I have also written SAS macro execution, wherein I am passing SAS help.class, and this will have the value of DSN. Means this SAS help.class will be passed on to here. And when I am passing 11 and it is start, so it will have the value of 11. And for end I am passing the value 15, so it will be 15. So whole of this will become proc print data equal to SAS help.class, first ops equal to 11 and ops equal to 15. So simply what we are doing here is we are trying to do a proc print for a particular data set and starting from a particular observation ending with a particular observation. There are few important points to understand in here. This is positional parameter. What does that mean? Whatever I pass here will be passed on to this value. Means I can't change the order. The order has to be same. So here we have start. When I have 11 here, it corresponds to this value. If we try to change the order, for example, if I want to put 11 first and then SAS_class, comma 15, what happens is 11 is the first value and DSN becomes 11. So this will become proc print data equal to 11, and this program is going to fail because our proc print is going to look into the value of 11. So the important point I want to mention in here is whenever we have positional parameters, the values we want to pass should be in the same position. Means whatever you want your DSN to be, you have to pass exactly as the first value. Whatever the start value you want to, it should be here. Whatever the end value, here. So this is position 1, position 2 and position 3. Our values should also match with that. So this is very important. Now let us look into keyword parameters. Before going into keyword parameters, I just want to re-emphasize one point. Each parameter is followed by a comma. Now here again the code is pretty much the same, but what I have changed here is I have written DSN equal to comma, start equal to comma, end equal to. This means I am creating 3 parameters in here, or I have 3 parameters in here, and these are DSN, start and end. Because I have equal to in here, equal to in here, equal to in here, these 3 parameters are known as keyword parameters. So again, whatever I pass for DSN equal to will go here, whatever I pass in here for start will go here, whatever I pass for end equal to will be coming in here while executing the code. So while executing the code, I am doing here %more functionality 1, DSN equal to SAS help.class, start equal to 2, end equal to 5, obviously with the commas after the each parameter I am passing. So this is very same to what you have looked into positional parameter, but it has some additional things to it. What is that? The first one is I can change my order. I can say start equal to 6. Again, it will just have the value 6 here. End equal to 9. I can do it in here. And DSN equal to SAS help.air. So this value will go for ampersand DSN. So the important point to remember is for keyword parameters, I need not follow the same order. Whereas for positional, I need to follow the same order. Again, whenever we are saying parameter, it is nothing more than we are creating a macro variable in here and we are using in here. And this is done through execution. Now that we have looked into positional and keyword parameter, I would like to get into one another point. For keyword parameter, I can also give default values while creating my macro. That is, in here I have given DSN equal to SAS help.class, comma, start equal to comma, end equal to. If you see, I have given the value of SAS help.class in here directly. This is another advantage of keyword parameter. So When I'm executing my macro here as percent more functionality 1 start equal to 2 end equal to 5, you got to remember that DSN is equal to SAS help.class. It is already there. I don't have to pass it again. So this is sometimes useful when you want to have default values so that you get your result. And not only that, we can also override this SAS help.class DSN equal to SAS help.class by mentioning again DSN equal to SAS help.cars here, start equal to end equal to. So we can give a default value and we don't have to pass the value, and also we can override that default values. Now one another important point arises is when do we use positional parameter and when do we use keyword parameter. Positional parameters we generally use when we have one or two parameters and then it is easy to pass. Keyword parameters generally we use when we have lot of parameters. That is when we want to have keyword parameter. The advantage with the keyword parameter is when you try to pass the values, you kind of know what you are exactly doing, which value you are passing. It is more clearer. So whenever we have more parameters, we generally go for keyword parameter. I have just now observed that I was missing comma earlier, but there should be comma after this second parameter in here. And now let's talk about how we can mix positional and keyword parameters. Yes, we can mix positional and keyword parameters, but all the time positional parameter should come first. Here we have another macro wherein we have two parameters DSN comma drp underscore call equal to. The first one is positional parameter, the second one is keyword parameter. So whenever we have this kind of setup, the positional parameter should always come first and then keyword parameter come second, or whatever it is. Basically your positional parameter should come before your keyword parameter start. And here I am passing the macro variables, or I am passing my parameters, and here I am giving the value of class which belongs to this position, drop underscore call equal to age. That is, drop underscore call will have age as value. If you try to switch, then we are going to have an error saying that all positional parameters must precede keyword parameter. Here we have created a macro, but what we have done is we have mentioned keyword parameter as the first one and positional parameter as the second one, and we cannot do that, and while executing the macro we get an error saying that all positional parameters must precede keyword parameters. Now let us briefly look into the differences between positional and keyword parameters. Positional parameters main property is the order in which they are defined, and we have to execute or pass the values in the same order. For keyword we don't have to do that. We can also mix keyword and positional parameters, but positional parameter should come first. And with respect to default values, positional parameters cannot have default values, whereas keyword parameter can have default values. Now let us look into compilation with macro parameters. Again, here I have a macro with a macro parameter, and then what happens is tokenization followed by the same process which we have discussed earlier. And when the macro processor sees percent macro and percent men, it stores the macro in macro catalog. Now let's also try to understand how execution happens with macro when it has a parameter. Now here we have our execution wherein I am saying percent test dsn equal to SAS help.class. Here I am passing the parameter. So whenever we try to do this, what happens is again the same thing, tokenization First, when it looks into %test, the macro processor, it opens this macro catalog and reads what is there in between this macro and mend. And when it sees dsn equal to SAS help.class, it creates macro variable dsn whose value is SAS help.class in local symbol table. And then whatever is there in here that is in between %macro and mend is put into input stack. And also ampersand dsn is also will be treated as text. And again the word scanner looks into this. As we have ampersand sign in here, the macro processor understands that, and what it does is it looks into local symbol table and it has the value of SAS help.class, and now this becomes proc print data equal to SAS help.class run, and now it is in SAS compiler, and the SAS compiler executes the code and it will do the proc print. Now let us try to understand compilation with macro statements and parameters. Here we have a macro. In this macro we have two parameters, and here we have our macro statement which starts with %if, %then and %do. Here the macro starts with %if and it also has %then and %do. And more on the macro statements in the future classes, but for now try to understand that macro statements have something like % in front of them. And here I want you to focus on few things here. Again, once we run this code, the code goes into the input stack, and again the word scanner looks into it, and when it encounters the % symbol, it compiles the macro and stores in the catalog. And another important thing to remember here is this %if, %then, %do statement is also compiled, because whenever we run any macro or whenever we compile any macro, we need to understand that all the macro statements are also compiled, which I have explained in the very beginning, and rest of them are treated as text. Now let us try to understand macro execution with macro statements and parameters. We can execute the macro by doing %test, which is our macro name, and then in parenthesis val equal to s, dsn equal to SAS help.class parenthesis close. Here we are passing our parameters as yes and SAS help.class. Now let us see what happens in here. Again the same thing, word scanner comes into picture and it tokenizes and it looks into this % followed by macro name. So what it does is it opens the macro catalog and reads whatever is there between %macro and %mend. And then when it looks into these macro parameters, it creates two macro variables, val and dsn in local symbol table. Val will have the value of s, dsn will have the value of SAS help.class. Now let's look into what is going to happen next. What's going to happen here is something more interesting than what we have done or what we have seen earlier. Here, as I said to you earlier, this macro statement will be compiled. During compilation, that is why it first looks into this macro statement, that is our if %then %do statement. What it does is it reads this ampersand val equal to s into the input stack first, and word scanner comes into picture. As ampersand val has the value of s in the local symbol table, the macro processor understands this ampersand val and it assigns the value of s to ampersand val, and this becomes s equal to s. Now our macro statement becomes as follows, that is %if s equal to s, %then %do. As this statement is true, whatever the text next is there in here, will come into as shown in here. That is proc print data equal to ampersand dsn run will come into input stack. Again, word scanner looks into this, tokenizes it, and then macro processor comes into picture as we have ampersand dsn, and ampersand dsn value is picked up from this local symbol table as the value of SAS help.class, and this becomes proc print data equal to SAS help.class run, and then it comes into SAS compiler and it runs the code. And further what happens is it moves to percent end. This indicates that the percent if then statement has ended. That is, our macro program statement has ended. And finally, we move further, and then here there is percent mend, and it indicates that macro has also ended and there is nothing more to read from macro catalog. And finally, this execution is complete. That's all for this topic. Today's topic is conditional and iterative macro statements. And this is part 4 of SAS Macro series. Now let us quickly discuss what are the topics we are going to cover. I'm going to cover percent if percent then, in which we will be talking about syntax and examples, and also what percent if percent then can do and when we should not use percent if percent then. And then we will go into percent do group. Here also we will look into syntax, example, and when it is useful. And also we will be discussing about percent do group in the context of using it in the open code. Then we will talk about iterative percent do loop. Again, here I will get into the syntax and also understanding implicit percent eval. And then we will be moving on to percent do percent while and percent do percent until. And here also we will discuss into syntax and examples, and also about how they are different. And also one example we will be discussing wherein I will be explaining how to write the code more efficiently. That is, how we can write our percent if then statements in a better way so that we avoid a redundant code. Now let us quickly look into simple percent if percent then. Percent if percent then should always need to be embedded in a macro, means we can't run this code out of the macro, so always it should be in the macro. And every percent if percent then should have a semicolon at the end. And also here another important point to remember is, here we are saying percent if ampersand macvar equal to test percent then percent put, this is correct input. So what we are doing is, depending upon this value, we are putting a text into the log. Here when we pass macvar equal to test, this is what we are going to see in the log. If you see this percent if percent then, it is very similar to if then what we use in a data step. One major difference in here is, here percent if we are using on a macro variable or we are using a text. It is very important to know that percent if percent then we are not using on variables. We are either using on macro variables or text. I will go into detail on this topic in the future slides. Now let us look into percent if percent then and percent else. Now here we have else and everything else is similar. We have our percent if then, and then we have semicolon. After that we can have percent else and semicolon. This is very similar to what we see in our data step, but in data step we have else if, and here we don't have any else if. And here percent else, as I said, it should end with semicolon. And when we pass our macro variable value, if the condition matches, then this particular statement is put in the log, else this statement is put in the log. Here we are passing the value test, so it's going to put this statement in the log, and that is what I have pasted in here. Now let us go a little bit deeper and understand the execution pattern and what happens. To understand how a macro is executed, it is always important to have options M logic, it tells about how your macro is executed. And also when you have percent if then, it also tells what's happening in your percent if then else statement. When we have options M logic and we are executing our macro with the value of macro equal to test, then what happens is it tells us that the execution is started and the parameter we have passed is test and the condition here is true. This third line, if you look a little bit deeper, it tells about what has happened in the execution. That is why we see this particular statement in the log. For the same macro, when we are passing new test, as this new test is not equal to test, this will become false and our else statement will get executed. Now let us also try to understand what else we can do with the help of percent if percent then statement. Percent if percent then statement, apart from creating the text, is also useful to create macro variables conditionally. Here we have a macro in which we have our percent if percent then statements, and in here if you see after percent then we have our percent let statement, wherein when the condition matches we are saying we want to create a new macro variable in which I am saying in here its name is new macvar and I am giving a value to it. So just not creating the text, but we can also create new macro variables conditionally with the help of percent if percent then statement. And when we pass macvar equal to class, this class becomes class and then the value of macvar we can see as SAS help dot class. Sorry, the value of new macvar as SAS help dot class. And apart from creating macro variables, we can do many other things, but let's also get little bit deeper. After conditionally creating macro variables like in here, we can also use them in the macro itself. For example, here we are creating a new macro variable by using percent if percent then and using a percent let statement, and the new macro variable which we have created we have used in here, and when we execute this by giving a class value, what happens is class becomes class and then new macro variable new macvar is created which we are using in here, and it has the value of sashelp.class and it proc prints sashelp.class. Not only creating macro variables conditionally, we can also conditionally execute macros with the help of percent if percent then. Here we have macro test and macro test one. They are just little different. We have different dataset names for both our proc print and proc means for macro test and macro test one. But we can conditionally execute this macro or this macro by using our percent if percent then statement in here. In here I have macro, a new macro which I am creating, and here I have percent if ampersand macvar equal to hello percent then percent test, which means when macvar, if I pass the value of hello, it will execute this macro. If we pass the value of macvar which is not equal to hello, it is going to execute test1 macro. If we see the two executions of percent both underscore test macros, what we have done is we have passed the value of macvar equal to hello, and this helped us to execute percent test, that is we were able to execute test macro, or when we have passed the value of hello 1, that is the condition has not matched here, it has executed test1 macro. Now let us talk about percent do groups. Again, this is percent do groups, and this is not about a loop or anything of that sort. Here we are talking more about groups. The groups we use generally, we want to address lot of SAS statements with semicolons or anything which has semicolons. Now let us try to understand more on this with the help of a macro in here. Here I have percent macro and I am naming it as do test and I have one parameter dsn equal to. In here I am saying percent if ampersand dsn equal to SAS help dot class percent then percent do proc print data equal to ampersand dsn semicolon run semicolon percent and then I'm ending my macro with percent meant. Here, let's focus on our percent do. What if I don't have this percent do and end? As you all know, every do should have an end, and in this case, we have percent do and we have percent end. And we have this percent do to handle these two semicolons. That is, one after this proc print statement, another after run statement. As I have said earlier, whenever we have just percent then and percent if, it should end with a semicolon. And here we have two semicolon. Percent then cannot handle two semicolons. What I'm saying is not 100% true. There are ways to handle it by using quoting functions, but that's an advanced topic and we are not going into it right now. We will be discussing more on when I'm going to discuss about macro functions. But percent if percent then ends after one semicolon. We can't embed multiple SAS statements in here. So to handle these multiple SAS statements with semicolon, we use do groups. So percent do is mainly to accommodate extra semicolons. Now let us look into the execution. Here we have percent do test and here we also have a small mistake. This is supposed to be dsn equal to SAS help dot class and I'm sorry for the inconvenience. And once we pass the value of SAS help dot class for dsn, here this becomes SAS help dot class equal to SAS help dot class and these statements will be generated and proc print will run. And we can also add percent else to this also. But unlike percent if, percent then, here we also have percent else and we also need to do a percent do and percent end. And this macro is pretty similar to what I have shown in you earlier. Only difference is we have a percent else macro statement also in here wherein we have percent %l, percent %do and we also are adding a SAS statements in here. Of course, these SAS statements are nothing more than text to your macro statements. And this is proc means data equal to ampersand dsn semicolon run semicolon and it ends with and we have percent. Now let's also try to execute this macro. Here I'm executing the macro and in here I'm giving dsn equal to SAS help.cars. The if condition does not match because SAS help.cars is not equal to SAS help.class. So the percent else condition comes into picture and proc means of SAS help.cars runs and the results you can see in here. So the bottom line, percent do group is very similar to percent if percent then, the only difference being the accommodation of more statements which have semicolons. Especially we need this whenever we have lot of SAS statements which have semicolons embedded within them. Now let us try to understand one another important aspect of percent do group. The advantages of percent do group is we can run percent do groups in open code also and this started from SAS 9.4 M5. As you have seen earlier, whenever we wanted to run any of percent if, percent then, percent do, all I was showing you to embed them in a macro and then run them. But starting from SAS 9.4 M5, for do groups, we do not have to have the whole thing embed in a macro. For example, I am showing the same thing what I have shown you before, but this is not embedded in a macro. There is no percent macro name, there is no percent mend, and I can just select this part and I can run, and then it executes and gives us the result we want. So here I have percent let dsn1 equal to sashelp.class, as it is sashelp.class equal to sashelp.class, and then whenever I run this code, it proc prints the result for me. %do group can also be used to conditionally execute macro in open code. Here we have %if, %then and %do, and then we are executing a macro whenever this condition matches. And finally we have our %end for this %do group. And here I want to tell couple of things. Earlier, whenever we want to use %if, %then, we have to embed them in the macro, but we are trying to use %if, %then, %do, so we can execute macro conditionally in open code. Another important thing is I have not put any semicolon after the execution, that is after %test. Macro execution does not need a semicolon, and if you don't put a semicolon, it is fine. So here I have defined my %let dsn1 equal to sashelp.class, and then this condition is matched in here, so this executes your macro. So %do group helps us also to make the code little bit simpler by not embedding them completely in macro whenever we want to do that. Now let us also look into something else which is important, that is how to think anything other than SAS macro statements as text and how it is useful. Now I want to illustrate this with an example here. In here I have a macro and I am calling this macro as simplify this, and my parameter is macvar equal to. Here I am having %if, %then, %do. When this condition matches, I want to have data sales, set sashelp.prd sale12, and I want to keep some variables followed by run statement and then end. For this %then do this end. If the condition does not match, that means whenever you pass a value which is not hello, then it should do this, that is %else, %do, data sales, set sashelp.prd sale, and keep some variables run, and then %end and %mend. So if you see here, depending on the condition, we are creating a data set in here or we are creating a data set in here. And the important point I wanted to understand in here is not to think in the terms of data step or data or anything else, but in the terms of text. Why I am saying this? If you see here, we have written 4 lines of code and we have 4 lines of code in here. Or for this macro, this is nothing more than text. So 4 lines of text, 4 lines of text. We have written 8 lines of text. But if we look closely, data sales is common in both the conditions and run is same for both the condition. So we can improve this macro by not writing this data sales and run multiple times. To understand this, what I have done is I have pasted the same macro what I have shown you earlier on the top and a modified macro in here. So what simply we can do is we can take the data sales out of these %if then statements and keep on the top And also what we can do is we can keep run also on the bottom. If you see here, I have moved data sales from here to top and run from here to bottom. So whenever the code gets executed, for example, whenever I pass the value of hello here, it becomes hello equal to hello, and it generates these two lines of text. And what happens is data sales is there on the top and run is there on the bottom. So it becomes data sales, set SAS help.pid sale and the keep statement with few variables and then run. And also if we are passing a value which is not equivalent to hello, what will happen is again it will generate these two lines of statements, and then we have data sales on the top, these two statements followed by the run. So it finally forms data sales set sashelp.pid sale and keep with few variables in here run. Bottom line, what we have to understand is what finally all these statements will become, means what are the text we want to generate and what is the text before and what is the text afterwards, and after executing what happens. This is very important point to understand and assimilate. We always need to think in the terms of writing less redundant and efficient code. Now let us look into another aspect wherein the new programmers often do mistakes on. That is, they will try to use %if %then statement on SAS data step variables. For example, here I have a macro, and this macro I am calling it as ABCD, and then I have data cars set SAS help.cars %if type equal to SUV then new equal to 10. So the new programmers often think that this type equal to SUV should be understood by this %if statement, but that does not happen. What actually happens here is when we execute this code, this %if then statement get executed first. So in this %if type equal to SUV then new equal to 10 gets executed. So the type will be treated as a text. This text is not equal to this text, then this then doesn't execute. So it is very important to understand that part. And then finally what happens is these data cars set sashelp.cars run, these statements gets created and they get executed with the help of SAS compiler, and then data cars will be created. Now let us try to understand this even more better by looking into the similar macro, but here I have my %if statement changed. Here I am saying %if quotes SUV equal to quotes SUV then new equal to 10. And then what happens in this case when we execute this macro, this %if statement runs first. As I've said to you very many times, this symbol is known as macro triggers and it runs first. As SUV equal to SUV, this then will generate this new equal to 10, and then what happens is then data car set sashelp.cars new equal to 10 run, these statements are created and SAS compiler understands them and it executes the code and a new variable is created. The point here I am trying to emphasize is %if then statements are meant for comparison of text or for the comparison of macro variables or comparison of text with the macro variables. Of course, the macro variable value itself is nothing more than a text. So be very careful in this particular point. Now we are left with percent do loops, wherein I would like to talk about iterative percent do loop, percent do percent until, percent do percent while. But before going into those details, it is again important to understand what macro variables are and little bit more about percent eval also we need to know. Now I can define my macro variable by percent %let statement as my mac var equal to 1 plus 2. And if I want to see this my mac var value, I can use a percent %put statement and I can reference my macro variable by using ampersand my mac var. And the result here we can see is 1 plus 2. So here this indicates that everything we mention in here is text. So we see the result also as a text and nothing happens even though we have a plus operator in here. But if we want the calculations to be done, we need to use something like percent eval. Percent eval is a macro function, more on the macro functions when we will be talking exclusively on macro function, and then we can do 1 plus 2. And when we look or when we try to see the value of my mac var 1, we can see the result as 3. So some calculations to be done, especially here addition, we need to use percent eval. Now I would also explain why I have told or why I have discussed this slide in a bit. But first let's look into percent do loop. Percent do loop is also very similar to what we have seen in a regular simple do loop. Iterative percent do loop. This is very similar to what we have seen or what we see in our data step do loop. It starts with percent do I equal to 1 percent to 5. Whenever we don't give by, it means we want it to be increment by 1, and we can have any statements in here. In our case, we are trying to find or we are trying to put this value to log, that is the value of I, and percent end. So percent do percent end is same, and instead of 2 we have percent 2. And important thing to understand in here is we are creating macro variable in here as opposed to variable when we use simple do loops. And also in percent do loops, we can execute whatever the code we have or whatever text we have this many times. But coming to the percent do loop in here, let's try to understand it better. When our percent do loop starts, the I value will be 1, and here you can see the value of I is 1, and then it increments by 1, it becomes 2, and then increments by 1, it becomes 3, then increments by 1 more 4, and it increments 1 more 5. It tries to increment one more time, but as the endpoint is already reached, it doesn't loop through anymore. And also remember, even though I have not shown you here, you can have a code here and can execute it multiple times. I have shown this example in very first macro class, wherein I have showed that how we can use proc append and run it 100 times. And I will give the link for the same in the description below. You can have a look into that also. Now that we have looked into percent do loop, now it is a good time to understand what really happens. As I told to you, macro variable is text, but if you see, I'm again saying that it is incrementing by 1. How is that happening? This is what is known as implicit eval or implied eval. Let's call it as implicit eval. So what actually happens when we create this macro and compile this macro, and when we execute this macro, what really happening is this. Our percent eval is running behind the scene, and what it does is it creates the value of 1 in the first step or in the first iteration, and then in the second iteration it adds one more, but behind the scene percent eval is running something like this, wherein after it becomes 2 it adds one more, percent eval runs behind the scenes. So the important point to understand in here is an implicit percent eval runs whenever we do percent do loops like this. And more on this implicit percent evals when we talk about functions in the next class. Now let us look into percent do, percent while and percent do, percent until, but I would like to start with percent do, percent while. And here for both percent do, percent while, we do not have a starting point and ending point like regular iterative do loop where you give a starting point and an ending point, or a start or an end. But they have condition mention after percent do, percent while. In until also it is the same. You say percent do, percent until, and you have condition mention in the parenthesis here. Now to understand percent do, percent while, let's look into this macro in here. In this macro, I am defining percent let I equal to 1, which means I am creating macro variable whose value is 1. Now I am saying percent do, percent while, and I am saying in here in the parenthesis the condition is ampersand I le5, means I want to loop while the condition is true when my ampersand I is less than equal to 5. Means when I am entering into the loop, if the condition is less than equal to 5, it should loop. And in here, as you can see in percent do while, when we initially start to go into the loop, the value of 1 is less than equal to 5, and as this condition is true, it goes into the loop. And we also have a percent put statement which puts the value into the log. And then we have percent let I equal to percent eval ampersand I plus 1. So percent put will put the value of 1, and we are adding 1 to this ampersand I, and it becomes 2, and our I will have the now value of 2. And it again goes and checks in the condition here 2 is still less than equal to 5, and it puts the ampersand I value, and again it adds plus 1 and it becomes 3, and it again loops through, and again it puts the value in the log. We are going to add 1 to this ampersand I, it becomes 4, and then 4 is still less than equal to 5, and then we put the value in the log, and then percent eval again, here we are adding one more, now it becomes 6, and then once it is 6 it tries to loop again. As it checks in here that ampersand I is no longer less than equal to 5, it comes out of the loop and it does not put or it does not do anything. So the values of this you can see in here. So percent do while is always about having a condition in here, and then you loop through it, and once the condition is met, the loop is ended with the percent end, and you can see the values of your I in here, and I have pasted this from the log. So to sum it up, percent do while, the condition will be there and it executes when the condition is true and stops when the condition is false. Here the condition which I have given is more about dealing with numbers. This condition could be anything. And one important thing about percent do while is If you give a condition which is always true, it will loop forever. And you have to be very careful about that and what condition you are going to give, and you have to see that the condition is not always true so that it can come out of the loop. And again, %do while, what it does is before going into the loop itself, it checks the value on the top. What does that mean? Here I have %let I equal to 1. Before going into the loop, it checks the value in here, then only it goes into the loop. Now that we have looked into %do while in a detailed way, now let's try to look in for %do %until. Everything in here is same except that here we have %do %until. Here I am saying %I greater than 5. %do %until execute till the condition becomes true. Means here the value is 1 till it reaches greater than 5. It loops through again and again and again and again until it becomes greater than 5, and once it becomes greater than 5, it comes out of the loop. So couple of things here. If we are giving a condition in %do %until which will never become true, it will loop forever. And again, in the case of %do until, here even though we have defined %let I equal to 1, it does not check on the top. It will loop at least once. This is something very different than what we have in %do %while. Say if the I is 6, it will still loop once and then only it will come out. Whereas in the case of %do while, it checks on the top. If the condition is not true, it will no longer go in the loop. These are some differences between %do while and %do until. And here in the %do until, the condition may not be related to numbers, it could be again anything. Now that we have covered a lot of concepts on %if, %then, %if, %then, %do loop, and %do while and %do until, I want to tell that now we have just learned fundamentals and how we can use these concepts. I will be capturing more of those in the future sessions. And with this, I want to conclude this topic. And today's topic is creating macro variables with Proc SQL and 3 ways to use them. Till now, we have seen 2 ways of creating macro variables. First one is %let statement and second one is SAS macro parameters. Both these require user input. But while creating macro variable using SQL, it helps us to use data from the table to create macro variables. In this way, it is different from what we have seen before. This helps us avoid hard coding. We will get into at least 3 case scenarios where I will explain you more in detail on this part. And these are great tools to handle metadata. By using dictionary.tables and macro variable, we can have so many applications, and I have made at least 4 to 5 videos on this topic itself, and link for the same I will give in the description below. Now let us see, by using data, what kind of macro variables we can create. We can create 3 types of macro variable. The first one is we can take a single value from dataset and we can create a single macro variable. And the second type is we can take multiple values from a single variable and we can create multiple macro variables. And the third one is we can concatenate variable values into a single macro variable. Each of these we will be trying to understand with very simple examples. Now let us look into how we can take a single value from dataset and put it into a macro variable. To do that, it is super simple. All we need to do is we need to write into and colon followed by macro variable name. This creates macro variable CNT. Now let us try to understand this example better. Now here I have written proc SQL no print because we are interested to create a macro variable. We need not print the whole thing. So I have written no print option in here after proc SQL. Here I am saying select count star into colon CNT from SAS help.class and then quit. What we are doing here is we are taking the value of count and we are creating macro variable CNT. So to create macro variable from proc SQL, it is super simple. All we need to do is into and colon the macro variable name. And we can reference this macro variable name, or we can use this macro variable by doing %put and then by referencing it by ampersand CNT. Here you can see that the value of count is 19. Now let us try to understand little bit more. Whenever we try to take a numeric value and put it into a macro variable, especially when we do it from the data, what will happen is it will create left spaces. And now let us try to understand with the same example we have seen earlier. Everything is same in here what I have shown you earlier, except that now I have a pipe around my macro variable ampersand CNT. Here I have a pipe in the front and a pipe in the back, or you can say pipe towards left and pipe towards right. And when we see the value in the log, we see a space after the left pipe indicating that there is a left space in here. And whenever we want to find the spaces in the log, especially as log has lot of empty spaces, we always try to do something like creating a pipe in front of macro variable or after macro variable or after any values, or we either use star or something, and this tells us whether there is a space or not. Here we can see that there is a space. To remove the space, it is super simple. All we need to do is we need to use trimmed option after our into colon macro variable, and once we use this trimmed option, and if we are doing the same %put and we have a pipe and ampersand CNT pipe, here you can see that there is no left space. Till now what we were doing was we were taking a single variable value and we were trying to put in single macro variable. But we can take many single variable values and we can put it into many single macro variables. Now let us try to understand this through an example. Here I have the same example what I have previously shown. In earlier example which we were looking into, what we have done is we have done count star and we have one macro variable created. Here I'm also interested in average age, so after count star comma I'm saying AVG and then I'm running it on age, and then I'm capturing into two macro variables. And to do that, it is quite simple. All we need to do is we need to write colon CNT comma and then we need to write colon AVG underscore age. So this count star value goes into this colon CNT. This average age goes into this AVG underscore age macro variable. So how many ever values you want to do, what simply you can do is you can follow it with a comma and then you can also create macro variable by putting a comma. And to trim these values is also very simple. all you need to do is you need to say trimmed option after colon macro variable and then comma another colon macro variable and trimmed. And now that we have looked into very simple case wherein we are taking a single variable value and putting it into a single macro variable. Now let's get little bit deeper and let's try to understand how we can create multiple macro variables by using a single variable but by taking it multi values. This is very powerful. But to understand this, now let us try to quickly do an example in here. In here I am saying proc SQL select name from SAS class semicolon quit. So what I am interested to see is I am interested to see all the values in the name variable. Here you can see that it has 19 values. I know this value because I work a lot with SAS class. And then what you want to do is you want to create one macro variable which has the value of Alfred, the second one will have Alice, and the third one will have Barbara, fourth one will have Carol. Like this, I want to create 19 macro variable and first one will relate to the first one in here and 19th one will relate to 19th value. So to do this, the code is also super simple. What I need to do is I need to write proc SQL again, as I do not want the values to be printed. I am saying no print, and in here I am saying select name into colon nm1 dash or hyphen colon nm19 from SAS class and quit. What we are telling in here is I want to create 19 macro variables starting from nm1 and ending from nm19, which means my first macro variable should be nm1, second one should be nm2, nm3, nm4 to nm19. So if you see the values in here, my first macro variable is nm1, it has a value of Alfred, my second value is Alice, and my second macro variable name is nm2, nm3 will have Barbara, nm4 will have Carol, and so on. So that we have looked into it, let's also do a percent put on ampersand nm1, ampersand nm2 and ampersand nm3. To find these values, we need to do ampersand nm4 to ampersand 19. But before going into that logic, here you can see that nm1 has Alfred, nm2 has Alice, nm3 has value of Barbara. If you see that this is rather tedious to look into these values and it defeats the whole purpose of looking into the values in this fashion because we have to type them out. But if you look deep into it, we can find a logic. That is, we have ampersand nm in front of all the values, but our 1, 2, 3, the numbers are increasing. They increase till 19. So what we can do is we can keep this ampersand nm constant and we can pass this 1, 2, 3 as macro variables. Now let us see how we can do that. So here what I am trying to show is we have created these macro variables, 19 macro variables. How we can access those macro variables without writing each one of them separately. Now let's look into how we can do that. And I have written my code on the top again to show what is happening. And here again you can see there are 19 macro variables created starting from nm1 to ending to nm19. As these macro variables are created outside, These are known as global macro variables. And these global macro variables we can use in a macro. Now, what we are trying to do in here is I have a macro which has name as check many macvar with do loop. So as I was saying, only 1 to 19 are changing. What we can do is we can, instead of using 1 and 19, we can use ampersand I. Here, to do that, what I am saying is percent do I equal to 1% to 19. In here, what I'm trying to do is I'm trying to access nm1 to nm19 by doing ampersand nm ampersand I. Whenever we have more than one ampersand, I have told that it is known as indirect macro variable reference, and I have gone into detail about this into one of my video, but I will go in lesser detail in here to explain this. So in here what is happening is when I is 1, that is in the first iteration we have macro variable value I as 1, and in here when we are starting from ampersand nm ampersand I, what happens is these two ampersands will become one ampersand, and this ampersand I resolves and it becomes 1. And now we have single ampersand nm1, and single ampersand nm1 value is nothing more than Alfred, and we see that value in the log in here. Now what happens in the second iteration is this is going to become ampersand nm2, and then by doing each iteration we are going to access all the macro variables from nm1 to nm19, and in here you can see in the result in the log after executing this macro that we are able to access all of these values. So whenever we want to access many macro variables which has a starting point and an ending point, we simply can create that starting point and ending point in a percent do loop, and then we can use indirect macro variable reference to access these macro variables. As I said to you earlier, I have covered about these indirect macro variable references in detail in one of my videos, and link for the same I will give in the description below. Now, even though this looks good, it has one important limitation. That is, we need to know how many observations are there in this dataset. In this case, I knew that there are 19 observations in SAS help class. If we do not know this one, then we have to open the dataset and we have to look into how many observations it has. And by doing so, by writing this manually here as colon nm19 and 19 in here, what we are doing is we are doing certain type of hard coding. What are the problems of this kind of hard coding? The main problem with this kind of hard coding is what happens if somebody wants to add 20 more observations into this SAS help class. Now this whole code becomes void, and this 1 to 19 also becomes void or pretty much useless, because we are not able to take all the values and create macro variables out of it as per our requirement. So to avoid this kind of hard coding, what we can do is we can simply use colon nm1 hyphen, and this started from SAS 9.4 M4. I think you don't have to give really the end value, that is nm19. SAS itself does in the backend. And also, as I said to you, we also want this to be automated, or also we do not want to hard code it, and this is nothing more than a count. So what we can simply do is we can do select count star into count or colon cnt from SAS help.class and then quit. I think I have written quit here, but probably it should be in here. And then I can simply try to access my macro variables by doing %do I equal to 1 to ampersand cnt. This ampersand cnt is nothing more than 19, and in here we are doing indirect macro variable reference and we are accessing all those macro variables. Now let us look into how we can do the same thing in the earlier version than SAS 9.4 M4. In here again the things are pretty simple and straightforward, but with one small change. In here again I am doing select count star into colon cnt and I am saying trimmed. I want my count value to be trimmed. And also in here I am doing select name into colon name1 and then hyphen colon nm ampersand cnt. In here this is going to become colon nm1 hyphen colon nm19. So in here we have to give the upper bound, but again we are not doing this manually, but we are simply using the count value which is captured into a macro variable. And when we come in here, ampersand cnt becomes 19, and now we are accessing all the macro variables as we have been doing previously. Now let me tell you why I have used the option trimmed in here. When I am having colon nm ampersand cnt, if I do not use trimmed, what will happen is this will have space. So it will become colon nm space and 19. So this will cause an error. So after using this option trimmed, what this will become is colon nm 19. Now we have seen how we can create many macro variables from a single variable and how we can access them. Now let us look into something different than what we have previously done. Now what we want to do is concatenate all the values into a single macro variable. If you look into here into the SAS help.class dataset, we have Alfred, Alice, Barbara. If you see, we have one value after another, after another. Now what we want to do is we want to create a macro variable which have all the values into one single macro variable, but all of these values concatenated with the help of a separator. Now let us see how we can do that. This can be simply done by using the following code, that is select name into colon all names. This is my macro variable, and this style we have been using previously. So we are creating only one macro variable, and also we are saying separated by space. And this is important. We have never used this word separated by and then any delimiter we want to mention in here. Here I am just mentioning space. And when we create this macro variable, if we do %put ampersand all names, this macro variable will have values like this. All the values concatenated as Alfred, Alice, Barbara, Carol, Henry, James. Now I want to discuss couple of things in here. In the separated by, I can give comma, I can give any other delimiter, and once we give a delimiter as comma, again one single macro variable we will have, and this will have the values like Alfred, comma Alice, comma Barbara, comma Carol, comma Henry, so and so forth till William. Now we have looked into how to create macro variables, but we have not gone into details how to use them. Now let us try to understand how we can use the macro variables that were created by Proc SQL into class. And in here I am going to cover three different styles. The first one is by simply using dataset values. And to understand this, let us look into a case study, or let's look into an example by which we can understand more. Here what I want to do is I want to create a table for each student name in SAS class. Without macro, how can I do this? Without macro, I need to write something like this. Data Alfred set SAS class where name equal to quotes Alfred, run. And for Alice, I need to write data Alice and where name equal to Alice, which everything being same. I need to write the same thing for 17 more names. Whenever we do this kind of thing, we have multiple problems in here. Our code becomes very long. What if we had 50 data sets to create? Then we have to write everything. We need to look into the data set and we need to write again. And one another problem is whenever somebody deletes or adds more rows, this code is not going to work. So long code depending on hard-coded values are the issues when we don't use any macro. And whenever we find that we are repeating most of the code, in this case if you see this code and this code is very similar, but the only thing is changing is dataset name and also the value for our where condition. So this kind of code can be simply made into a macro. Now let us try to make a simple macro. In here I am making a simple macro wherein I am saying percent macro simple mac val equal to, and then I am saying data ampersand val set SAS class where name equal to ampersand val, and I am putting this into double quotes because macro variables are resolved in double quotes, not single quotes, and then run, and then I'm ending my macro with %med. Now I have created my macro, and again I can execute this macro by passing Alfred, Alice and 17 more execution. The code is a little easier, little simpler by putting this into a macro, but still it has quite a few problems. Instead of Alfred, A in the capitals, if I give A in small letter or if I write the spelling wrong, the data set will not have any rows. So manual entry, and there is an issue, and if somebody adds or removes any rows, then we are going to have a problem because again we need to add one more execution or 20 more execution. So the approach with a simple data step is repetitive code and hard coding, but whereas with a simple macro, even though we do not have very much of repetitive code, but there is an issue of hard coding. How we can address this? It is again simple, and this is what we have already seen, but let me show you once again how to do this. In here I am creating a macro, and in here I am saying proc SQL no print, and in here I am creating my macro variables by doing select name into colon name1 hyphen from SAS class. This will create 19 macro variables, and I have also have my count star into CNT macro variable, and in here I am doing %do I equal to 1 to ampersand cnt, and this becomes 19. And here I am accessing all the macro variables nm1 to nm19 by doing indirect macro variable reference, and this I am doing for data ampersand ampersand nm ampersand I, and also in my where condition. So this becomes ampersand nm1 means this has a value of Alfred, and this also becomes ampersand nm1, and this becomes Alfred, and this creates our Alfred dataset. When it goes to second iteration, it makes it Alice dataset, and then it makes Barbara, and so on and so forth till the William. So what is the advantage of this kind of approach? Now we are directly pulling the values from the data set and we are using them without manually entering it or without hard coding, which means this program is almost the which means we are making this program very dynamic and data driven, and this leads to no manual errors, especially related to values. Now let us quickly try to compile this macro and run this macro. Now I am also compiling and execution in one step, and then in here if you see that I have created 19 data sets, each of them have one single row. So the first approach what I was telling about is simply using dataset values. Now let us try to understand what is the another way that we can use macro variables created into Proc SQL into class and solve some problems. And this involves dictionary.tables, and there are some other related tables also which belong to dictionary library. Before going into the details of dictionary.tables, now first let us look into what is the problem we want to solve. Here I want to proc print all data set which start with A in SAS help, and I just want to proc print first 5 rows. Here if you see the SAS help library, I have 1, 2, 3, 4, 5, 6, 7, 8 data sets which start with A as the word. And then how can I solve this without using any macro? Again, I can simply use proc print data equal to and SAS help dot the dataset name which we want to, and then ops equal to 5, run. So I can do for all the 8 data sets very easily. But what is the problem here? If I have 50 data sets, how can I do the proc print? It becomes tedious and it becomes redundant code, and this kind of code, as explained to you earlier, it is better to use macro variables. Now you see everything in here is same except the dataset name is changing. So what I can simply do is I can pass a parameter, and then I can execute all these macros by passing the dataset name as a macro parameter. But it is the same problem what I have previously discussed. That is, we are hard coding, we are passing hard coding values. If there are more data sets, then this code is not going to work. If some data set is deleted, the code will have different problems. Now how can we solve this? We can solve this with the help of dictionary.tables. Now let us briefly try to understand dictionary.tables. I have made couple of videos on how to use dictionary.tables and proc SQL into class, and link for the same I will give in the description below. And I have also discussed about dictionary.tables little bit more in depth in those videos. And now let's look into dictionary.tables and what kind of information it has. Dictionary.tables has all the information related to tables which we have in a SAS session. Now let us quickly try to run select star from dictionary.tables, but let's only look into 5 records real quick. Now when I run this proc SQL outops equal to 5 select star from dictionary.table semicolon quit semicolon, we see that we have 5 rows in which we have the information related to data sets, and in here you can see that we have libname, memname and many other variables. And for our case we do not really need these many variables to understand, but we are interested in two variables. The first one is libname and the second one is memname. If you see here, libname tells about the library and memname says about the dataset name. As I was explaining earlier, we are interested only in SAS help library. So to look into or to get the information from SAS help, we just need to modify our code little bit, and we need to add here a where condition, and we need to say where libname equal to SAS help. It gives us all the tables related to SAS help. Now let us quickly run this piece of code and see the result in here. Here again I am using outops equal to 5 and it gives me all the 5 data sets. And now I am actually interested in all the data sets which starts with A. How can I do that? After writing where libname equal to SAS help, I just need to say and memname like quote A percent symbol quote, means I want to find dataset names which start with A but it can have anything after A. And let's quickly run this. Now here we can see all the datasets related to A. Now all we need to do is we need to run the same code and make each one of these as a macro variable and run this in the loop to do the proc print. Now let us look into that code. I have placed my code into this macro wherein I am using the same where condition which I have discussed earlier, but I am capturing these memname values into macro variable and the count also into a macro variable. Now we are running the same loop what I have shown you n number of times before, wherein we are saying %do I equal to 1 to %2 ampersand cnt, and in this case this is going to be 8, and dsn1 will resolve here as whatever the data set in there, and it will do the proc print, and then when I becomes 2, then this becomes ampersand dsn2, and whatever the value is for ampersand dsn2, that resolves and that also gets printed. And let's now quickly run this code and see what is happening in here. Now here you can see that we have printed 7 datasets in here, sorry 8 datasets in here, but if you see even the code is wonderful, it works fine, you don't have to manually do anything, but there is one slight problem with the proc prints in here. We do not know from which datasets these are. To know each proc print belongs to which dataset, all we need to do is we need to have the same code, but we need to have a title, and here I am saying title printing of SAS help dot ampersand ampersand dsn ampersand I quote semicolon. Here again I have double quotes because macro variables resolve in double quotes only. And in here this becomes ampersand dsn1, whatever its value is there, that will be printed in our title. Now let us quickly run this code and see what is happening in the result here. Now you can see that it tells us what data set it belongs to also. So not only we have automated a lot of things, but we have proc printed the datasets in such a way that it tells us which dataset it belongs to. Now that we have looked into two different ways of using macro variables related to Proc SQL into clause, now let us look into the third way. The third way is another important way, and it is by creating control tables. Before going into the details of this, now let us look into our requirement. Requirement is to print 5 tables, and this list can change. And also, this proc print should be done by 20 people in a team, which means you need something which happens at one place and everybody uses the same thing. Say for example, if I told 20 people to do a proc print of 5 tables, they will do it. If it changes, I need to communicate with the 20 people saying that, hey, now you need to add one more data set. So this kind of communication and trying to do without automating is problem. So in these kind of scenarios, what we want is we want a solution in which we are handling everything from one particular table, and this table is known as control table. So this control table will have all the information. In here I have 4 tables. Sorry, here I have mentioned 5 tables, but I am creating my control table with 4 tables in here. So my table will have all the table names which I wanted to proc print. This is known as control table. And we use this control table and we will create macro variables from this control table, and then we will do the proc print out of it. So what happens if somebody adds a row? It's fine. When we are doing dynamic coding, like what I've been showing you from past half an hour or so, it will take care of everything. And in here, let's first create our control table which has all the information we need. Now I have created my control table and it has 4 rows. And again, I can proc print by doing the same thing what I've been showing you over and over. That is by doing select and then the variable name into macro variables which we want to create, and also count star into count, and then we are doing our proc print. And then let's quickly run this. And here you can see that it has proc printed all the 4 data sets. So if I want to make 20 people to do the same thing, then what I can do is I can create a control table. Here if I want to add a row, I can simply add a row. That is, I want to proc print one more data set. I can quickly run an insert statement, and this inserts the row. And once the insert is done, I don't have to do anything to my macro, or not even the 20 people who are using that macro has to do anything. So I can simply run my macro once again and it will proc print this data set too. And now let's see the proc print. It will show the proc print of the data set which I have just added. So apart from directly using the values into dataset and also dictionary.tables, control tables is another way to create macro variables by using proc SQL into clause and then solve some problems. Before wrapping up this topic, I would like to inform one another thing. So if you looked into all of our macro variables which I have created, are many macro variables I have created and looped through them. But I have not used a single macro variable of this sort and solved a problem. I will show this kind of solving the problem once I talk about macro functions, and then I will show you how to solve this with the help of percent do percent until and percent do percent while. In that way, we will know another way of solving the problems, and also we will know how to use percent do percent while and also percent do percent until in the next sessions. And that's all for this topic. In the last part, that is part 5 of SAS Macro series, we were discussing about Proc SQL into clause where we were able to create macro variables. Today we will be talking about how to create macro variables in data step using call SYMPUT or call SYMPUTX, and also I will very briefly compare how to create macro variables by Proc SQL into clause and also call SYMPUT, especially to show you which one is easier, not to contrast something but to show how easy one is above other. Now let us quickly look into what are the topics we are going to cover. The topics I'm going to cover today is what is call SYMPUT and what is call SYMPUTX, and what are the differences between both of these, and what are the advantages of call SYMPUTX. And also we will briefly look into the comparison of proc SQL into clause with call SYMPUTX. Now let us go into brief introduction. This is the introduction which is pretty much close to what I have discussed with proc SQL into clause. Both proc SQL into clause and call SYMPUTX helps us to create macro variables from data. But call SYMPUT and call SYMPUTX help us to create macro variables in data step. And both of them helps us to avoid hard coding, and these are great tools to handle metadata. By using dictionary.tables and macro variables, we can have n number of applications. Now let us quickly look into call SYMPUTX. In here I am using a data step. In here, as I do not have any data or I do not want to create any data, I am saying data underscore null underscore, and in here I am having a variable var and I am giving its value as hello world. In here I am using call SYMPUT to create macro variable. For call SYMPUT, the first argument which I am giving in here, which is in quotes, is macro variable. Second argument is my variable, both are separated by comma, and in here it need not be the variable, but it could be directly the character value in here. That is, I can just use hello world in here, and I can create my macro variable which has the value of hello world. But in this case we are using var as my second argument, which is nothing more than my variable. And call SYMPUTX is also pretty similar. We have two arguments. The first argument is nothing more than my macro variable name, and the second is my variable name, and this macro variable will have the value of var. And I am putting both of these values into the log by using pipe in front and back of my macro variable. In here I am doing both for ampersand macvar and ampersand macvar1, and both the values resolves to hello world. This is to show that we are able to capture the value of variable and we were able to take that value into a macro variable. So this is one important thing to remember. By using data step call SYMPUT and call SYMPUTX, we were able to capture the value of variable into a macro variable. Now we have looked into a character variable. Now. Now let us look into a numeric variable in here. In here everything is same, but my variable value is a numeric value, and I am doing a call SYMPUT and call SYMPUTX, wherein I am saying nmacvar and then putting that into quotes, comma var And for call SYMPUTX, I'm saying nmacvar1 quotes comma var. Again, this var value is captured into the macro variable. Same is the case with call SYMPUTX. And I'm having a pipe as previously what I've shown you for both of these call SYMPUT and call SYMPUTX macro variables, that is ampersand nmacvar and ampersand nmacvar1. Here I want you to focus little bit more. For call SYMPUT, you can see there is a left space, whereas in the case of call SYMPUTX, there is no left space. So call SYMPUTX, what it does is, whenever we have a numeric value, it does not keep the left space, it removes the left space, whereas in the case of call SYMPUT, it does not remove the left space. If you look, or if you remember from what we have done in the proc SQL into clause, in the proc SQL into clause also, whenever we were taking a numeric value into a macro variable, we were having left space and we used trimmed there. So proc SQL into clause plus trimmed is what is called SYMPUTX. So call SYMPUTX you can use in the data step, and you can take a number, and it also creates a macro variable and removes the left spaces. Now let us quickly look into what are the differences between call SYMPUTX and also call SYMPUT. One of the major differences what we have seen was call SYMPUT, whenever we create a macro variable from a numeric variable, we have left space. For call SYMPUTX, we do not have left space. Another difference is whenever we use a numeric variable and we create a macro variable, as I am showing with the call SYMPUT here, we will have a note in the log saying numeric values have been converted to character values at the place given by line and column. Whereas with the call SYMPUTX, we do not see those kind of note. So with these two aspects, the call SYMPUTX looks little bit more comfortable to use. Now let us look into another aspect or another difference between call SYMPUT and call SYMPUTX. Before going into those details, I need to discuss one important point. That is, whenever we create macro variables in a macro, usually they are local macro variables that are created. Local macro variables means macro variables are just related to that particular macro, but they are not available outside of the macro. But when we create macro variables outside of the macro, they are usually known as global macro variables, are available for macro and for any other programs to use. I need to tell one important point here. This is a gross generalization, I am doing it. More on this topic we will learn when we talk or when we discuss about scope of the macro variables. And again, call SYMPUT is little bit more complicated when we talk about their scope, especially when we are creating them in a macro. For now, let's just focus on what are the differences between call SYMPUT and call SYMPUTX in the context of options they provide. Here I have a macro. In the macro I am saying macro test and I am saying var equal to. My parameter is var and then I am saying equal to. And then I am saying data underscore null underscore, and I am using my call SYMPUT and I am creating my macro variable m underscore macvar and ampersand var. Means whatever the value of ampersand var will be the value for this new macro variable m underscore macvar. And call SYMPUTX, if you see here, I am having a third option. As I said to you, whenever we create macro variables in a macro, they are usually local macro variables, but call SYMPUTX gives me another option, that is G in here, to create a global macro variable. Again, this topic is much more complicated than what I'm saying, but what I want you to focus on in here is call SYMPUTX can take 3 arguments, whereas call SYMPUTX takes 2 only. And after my data step is completed, after run, I'm doing %put underscore user underscore. And after %man, once I compile this macro and execute this macro, here I am passing the value of hello. In this macro, we have asked to do %put underscore user underscore. That is, we want to see all the user defined macro variables. And that is what we see in the log in here. We see many more macro variables, but I have not shown you that for simplicity. But I want you to focus on these 3 macro variables and their scope. Whenever we have a result like this, the first one is scope, second one is the macro variable name, third one is its value. Here, my macro variable scope is test, means the macro variable m underscore macvar just belongs to this macro and its value is hello. Same is the case with the var, its value is hello in quotes and it just belongs to this test macro, which means both of these are local macro variables, whereas m underscore macvar1 is a global macro variable. As I have given an option of G in here for call SYMPUTX, so it has become a global macro variable, and m underscore macvar again has a value of hello. The important point to remember here is call SYMPUTX gives an additional option to define the scope. It is not that we can only define G, we can also define L, that is local, but again all of this we will discuss in future sessions. Now let's move further ahead. Till now we have been taking one value and we have been putting into a macro variable. Now let us see how we can make multiple macro variables using call SYMPUT. And in here what I want to do is I want to take all the values in a particular variable. In here I have SAS help.class and I have the variable name as name and it has 19 values. I want to make macro variable for each value. Now let us see how we can make this possible. In here I'm using call SYMPUTX, but I have not shown you something before is using a dataset in here. So I'm starting with data underscore null underscore followed by a set statement wherein I'm saying set SAS help.class semicolon and then I'm using call SYMPUTX. And in here I have 2 arguments. The first argument is cat, which is CATT, followed by parenthesis nm comma underscore n underscore parenthesis closed. This whole is one argument and this argument contains my macro variable name and the second one is my variable name. So let us look little bit deeper into this argument wherein I am giving more of a SAS expression wherein I am trying to concatenate nm with underscore n underscore. Underscore n underscore represents the number of times data step has iterated and it starts with 1. I have made a video on this topic and link for the same I will give in the description below. As I said, it starts with 1. So when in the first iteration we will have the value as Alfred, that is name will have the value of Alfred, and this becomes nm1 because we are concatenating both of this. Now our macro variable name will be nm1 and it will have the value of Alfred. When it goes into the second iteration, that is when it reaches the second observation, what will happen is this becomes nm2 and the name will be Alice. And in the same fashion, this underscore and underscore will become 3 and we will be reading Barbara. So our new macro variable will be nm3 and it will have the value of Barbara. In the same fashion, as we have 19 observations, what will happen is it will create 19 macro variables and underscore will increase by 1 after each observation and the name value will also change. In this fashion, what will happen is we are creating 19 macro variables with nm1, nm2, nm3, nm4, nm5, nm6 till nm19. So in this way, we can create multiple macro variables in call SYMPUTX. So to do that, here what we are doing is we are using underscore and concatenating with a string to create multiple macro variables. Now let us see how we can reference these multiple macro variables. And I have made a very detailed video on this topic, how to access multiple macro variables. The concept is absolutely same. The only difference is the way we create macro variables, which I am showing you in here from data underscore null and run, and the do loop wherein we are going to access all the macro variables is exactly same as what I have discussed in Proc SQL into class, and link for the same I will give in the description below. Now to go into the details, here I am creating a macro and I am calling its name as mini macvars, and in here I have data step wherein I will be creating many macro variables as shown in here and we have discussed in detail in the previous slide. Apart from that, we are also creating another macro variable CNT, and in here I am saying call SYMPUTX CNT comma n. Now let us try to understand what this n is and what its value is. So after our set statement, we are also saying n ops equal to n. What this n ops equal to n does is it will create a temporary variable n and it will have the value of number of observations in SAS help.class. Again, n ops is a little bit complicated topic. It is not as straightforward as what I'm trying to say, but for now, for this topic, this is good enough. What we are doing is we are capturing the value of number of observations and putting it into a temporary variable n, and now the macro variable cnt what we are creating in here will have the value of 19 because n is 19. And now we are looping through this. How are we doing it? We are doing %to I equal to 1 %to ampersand cnt semicolon. As I said to you, ampersand cnt is nothing more than 19. So now our loop starting point is 1 and ending point is 19. And by using %put statement, we are going to access these macro variables by writing ampersand nm ampersand I. And this kind of reference in which we do multiple ampersands is known as indirect reference. And I have made a video on this topic also, and link for the same I will give in the description below. And in here what happens is wherein we have ampersand nm ampersand I, 2 ampersand will become 1 ampersand in the first pass, ampersand I will become 1 in the first iteration. So now we are accessing ampersand nm1 and its value is Alfred. That is what we see in the log. When I moves to 2 in the second iteration, this ampersand name ampersand I becomes ampersand nm2 and it resolves to Alice. In the same fashion, till 19, we will be creating macro variables starting from ampersand nm1 to ampersand nm19, and we can access the macro variable values by doing so. Here in the result you can see that we are having the values of Alfred, Alice, Barbara, Carol to William just by having this ampersand nm ampersand I. Now, please also check out my another video of Proc SQL into clause. I go little bit more deeper on this aspect in that particular video and I do not want to again repeat myself. Now, let us try to compare call SYMPUTX with Proc SQL into clause. Functionally, they are both same. What we are trying to compare here is ease of use, in which we can easily get the results we want. Now let's try with call SYMPUTX. And in here I am trying to show something different than what I have shown you previously. In here we have call SYMPUTX and we are creating a macro variable YR. For second argument, what I am doing is I am using today function. Today function gives the information related to current date. On top of it, I am using an year function. An year function pulls year from any date which we provide. As we have provided today's date, the year function, what it will do is it will pull the current year, and this current year value will be taken by our macro variable, which means our macro variable will have the value of 2022. And if we do a percent put ampersand YR, here you can see that the value is 2022. Now, before going into Proc SQL into clause, I would like to say one more word. So, the second argument need not be just a string, number or a variable. It could be any SAS expression which resolves into a result, and this result can be picked up by this macro variable. And to do the same in Proc SQL into clause, we need to write Proc SQL no print, and then we need to say select distinct, and then we need to apply our two functions in here and then do into and then colon our macro variable name from SAS help.class or any dataset here. So the main problem in here is Proc SQL does not allow us any query to be valid without having a from clause. So what will happen if we do like this? It is going to read all the records from SAS help.class even though we are not using anything from it. So what looks like a pretty simple thing in call SYMPUTX looks unusual and complicated in Proc SQL into clause because we are using a distinct here and also we are using some data set which has no relevance with this one. So whenever we have to use a single value without a table, call SYMPUTX is best. Something like the year and today functions which we have been using, and to create a macro variable, always go for call SYMPUTX. Now let us look into the next comparison. Concatenating all the variable values into a single macro variable. Now let us try to understand this by looking into SAS help.class dataset. What here we want to do is we want to take the name variable and we want to concatenate all of these values into one macro variable. And let's see how we can do this by using Proc SQL into clause. With Proc SQL into clause, all I need to do is I need to say select name into colon macro variable name separated by a delimiter. Here the delimiter is space from SAS help.class. What this does is it concatenates all the variable values if you can see in here. And what it again does is it puts all the concatenated values into a single macro variable, and in here we are calling that macro variable name as all names. And when I do %put ampersand all names, you can see that this macro variable has all the values of variable but in a concatenated form. Now to do the same thing in data step and to use call SYMPUT or call SYMPUTX, it becomes little bit more complicated. In here, it is not as automatic as in here where I am just saying separated by a delimiter, everything gets concatenated in the back end and then we get our macro variable with all those values in it. Here, we need to provide a logic, and that logic in the data step concatenates all the values. Once that concatenated value we get, then we can do a call SYMPUT or call SYMPUTX to get that value into our macro variable. From length statement to end, we have that logic wherein we concatenate all the values and put it into a variable, and this variable which we have created and which has all the concatenated values is then used in call SYMPUT. Now if you see here, this is lot of logic, but whereas in the case of into clause, this is way simpler. So whenever we want to concatenate variable values into single macro variable, I would always prefer proc SQL into clause. And now let's look into another aspect. That is how we can use or apply these macro variables which we have created in call SYMPUT or call SYMPUTX. And we can do this application by three different ways. The first one is by simply using dataset values and creating macro variables out of it and then solving some problem. Or we can use dictionary.tables or related tables. And when it comes to data step, that is where we are creating our macro variables for call SYMPUTX. These tables are known as SAS help v tables. And the third application is by doing control tables. I have made a very detailed video on this topic in proc SQL into clause, and link for the same I will give in the description below. Even though we can create macro variables by call SYMPUT or by proc SQL into clause, the way we use them is same. And basically we use in one of these three styles and we solve some general problems. Now it's time to wrap up the whole topic. When compared between call SYMPUTX and call SYMPUTX removes left space when we try to make numeric value as macro variable, whereas call SYMPUTX does not do that. Call SYMPUTX also can take more options to make a macro variable global or local. And also, call SYMPUTX does not throw a note when we are using a numeric value and converting into a macro variable, but call SYMPUT does gives us the note. And also, when comparing call SYMPUT or call SYMPUTX with proc SQL into clause, call SYMPUT is good to handle single value into single macro variable than proc SQL into. Concatenating variable values into a single macro variable is easy to handle in the case of proc SQL into clause rather than by doing it with call SYMPUT or call SYMPUTX. That's all for this topic. Today we are going to talk about SAS Macro series part 7a, and it is about macro functions, and especially it is about macro quoting functions. I will be also having another part 7b, which is again also related to macro functions, but everything other than macro quoting functions. Macro quoting function is often a complicated topic and it is sometimes very difficult even to understand. So I have made my efforts to make it as easy as possible, but this is a little bit longer topic. Now, in the macro functions, we have quoting functions and also other types of SAS macro functions. But for today's topic, we will be completely focusing on macro quoting functions. These functions are very useful to mask special characters and mnemonics. Now let us try to understand coding functions with the help of an example. Here I have a %let statement wherein I am saying %let h equal to proc print data equal to SAS help.class semicolon var name age semicolon run semicolon and then final semicolon for this %let statement. I would like to iterate one another thing which I have been telling from the very first class, that everything and anything in a macro variable is nothing more than a text. And now what we are really doing here is I'm trying to put a bunch of text in here and then try to run my %let statement. But when I run the %let statement, I get an error here. That error says that var is something excess in here. Means this should have ended somewhere in here. That is my %let statement h equal to proc print data equal to SAS help.class. This should end here. That is what my error is telling about. What does that mean? It means that this semicolon here is interpreted as end of %let statement by microprocessor. But I want this to be treated as text, which means I want this also as a part of my macro variable. And also when I do my %put, the value I see is only proc print data equal to SAS help.class. Even though I want whole of this till run semicolon to be part of my macro variable, but it is not happening because a macro processor is thinking that this semicolon in here should be the end of %let statement. What now I want to do is I want to apply some function which will tell the macro processor that this semicolon is not really the end of this %let statement, but this is the part of text. Now let us try to do that by using %str function. In here I am using %let and I am saying h equal to %str and I am putting everything into parenthesis in here. That is, I am applying %str function on the text what I have shown you before, and this final semicolon is for this %let statement. Now all these semicolons are treated as text. How they are treated as text, I will go in detail into that topic also, but for now let's try to think that this %str helped us to treat this semicolon as text. And when I do %put here, it gives me value as proc print data equal to SAS help dot semicolon var name age semicolon run semicolon. And before going into anything else, what I would also like to say here is I have been showing you a new way of looking into macro variable. That is, I'm using %put ampersand equal to h semicolon. Earlier I was just trying to use ampersand h and then looking into the log. But what you can really do is you can really do %put ampersand equal to h. It will show the macro variable values as follows. It tells macro variable equal to and the macro variable value. This is a new way of looking into macro variable value, and I think it started somewhere from SAS 9.4 M4 or something of that sort. And then this is easy to see in the log. Now let us look into our main topic. What this macro quoting function is doing is it is instructing macro processor to treat semicolon as text. Now let us look into what are the other special characters which gives us problems with macro processor, like the semicolon we have seen. And also after that we will look into how macro coding functions work behind the scenes. Now let's look into what are the characters which give us problems. Some of the characters which give us the problems are shown in here. Those are plus, minus, star, and forward slash, and others. And also some mnemonic characters also give us problems, and those are and, equal to, greater than, gt, and others. So what our quoting functions they do is they mask these special characters which cause problems during compile and runtime. I will also get into what does compile and runtime quoting functions means, but first let's quickly look into quoting functions and how do they work. In the earlier slide, I have shown you the way we can apply a masking function. That is by simply writing the name of masking function. Here it is %str followed by parenthesis and whatever we want to write in here, and closing the parenthesis followed by the semicolon for this particular scenario. In here, what macro coding function really does is it applies hexadecimal masking characters, and these are also known as delta characters, and later they are unmasked. Here we need to also understand that macro subsystem understand these special characters and they mask them. Here if you see that the special characters are semicolon and they are masked. And also I want to tell one another thing here. The beginning and ending of this whole thing is also masked, but that is not important to know, and I'm not going into very fine details of the masking. But what I want you to understand is special characters are masked here, and that is when we are applying our %let statement. What is happening is this %let statement wherein we are saying h equal to all of these, what happens is all of these semicolons are here masked. So once they are masked, system does not understand it, or our macro processor just simply doesn't understand that as semicolon, and we do not have any problem with the semicolon after masking them. And I also said that once we mask these characters, they are also unmasked. And now let us see how we can understand that these things are also unmasked. Once we apply option symbol gen and then we do our %let statement in here, and after that once we do our %put ampersand equal to h semicolon, we can see a message in the log. That message is some characters in the above value which were subjected to macro quoting have been unquoted for printing. That means the values were quoted here and they were unquoted when we were doing our %put. This is very important to know. Now let us see how we can understand this visually. This kind of visual we have seen earlier when I was discussing about introduction and also about %let statements. Now whenever we run a piece of code, first it goes into input stack and word scanner looks into it, and what it does, it tokenizes into literal numbers, name, and special tokens. Here the %let is a special token. As it has a % symbol, macro processor understands it because they are macro triggers. macro processor understands it, and what it does is, because we have a %str in here, it stores the macro variable macvar in simple table by masking of all of these values in here. And once the macro processor is done, that is when we do our %put, the values are demasked, and especially this is done once our macro processor work is done. And here you can see that we have demasked values. So the important thing to understand in here is only one. That is, when the macro processor is working, what we are doing is we are masking those special characters which are interpreted in a wrong way by the macro processor. In our case, what we were discussing that as semicolons, because whenever we use %lt statement, semicolon is usually treated as end of that %lt statement. By masking, what we have done is we have not allowed this macro processor to see that semicolon. So our %lt statement has not ended here, but whole of this has been our macro variable value. This was done with the help of masking, and once the macro processor work was done, it is demasked and we can have all the values back. Probably I should use the word unmasked rather than demasked. In here, what I mean to say when I say that the values are unmasked and the values are back means the values or the text which were masked, in our case semicolon, they are unmasked and they are part of the text in here. Now let us talk about different kinds of macro quoting functions. If we talk about the categories, there are two categories of macro functions. The first one is compile time and the second one is runtime. Till now, we were talking only about %str, and %str is compile time function. And it masks all the special characters which we have earlier discussed except % and ampersand. nrstr also masks all special characters and it also masks % and ampersand. Now coming to runtime functions, there are three of them which are important. One is %bquote. This also works very similar to %str, but it's more a runtime function. And it masks all the special characters, but it does not mask % and ampersand. nrbquote masks % and ampersand along with other special characters. Percent super q is very similar to %nrbquote, but it has its own nuances and it is little different. In here, the macro variable never resolves, and the way we access macro variable is also different. More on this in coming slides, but for now, just try to understand that %super q is similar to nrbquote, but it is little different. I have discussed only few macro quoting functions. There are few more macro quoting functions. I feel that these are most of the time enough to run our macro code. And also it is very important to understand that macro quoting is often little complicated topic, and its complexity often comes from the difference in compile time macro quoting functions and runtime macro quoting functions. Now let us try to understand what is the difference between compile time macro quoting functions and runtime macro quoting functions. It is not very easy to understand the differences between the compile time and runtime macro quoting function when we do it or when we try to understand it from open code. Whenever we create macro variables or do something which is not embedded in a macro is often known as open code. Now let us try to understand the differences between compile time and runtime macro coding function. And then we are going to do this with the help of a macro. In here I am creating a macro and I am calling it as test1. In here what I am doing is I am trying to create two macro variables. The first one is S and the second one is B. And here I have the same text what I have shown you previously related to proc print. In here I am using %str, which is a compile time macro coding function, and in the second case I am using %b code. Apart from creating macro variables, what I am doing is I am also trying to access these macro variables, or rather I would say I am trying to see how these macro variables are stored in symbol table. And I can do this by simply doing %put underscore user underscore. What this does is it shows all user defined macro variables in this macro. That is, we have two user defined macro variables. The first one is S and the second one is B. And once we run this code from %macro to %men, this is what we call as compilation. It is very important to know what happens in the compilation phase. In the compilation phase, what the macro processor does is it looks into macro statements. As you can see, there are no macro statements in here. And the second one, what it does is it creates all the things which are needed as text. That is, whenever we have any macro variable to be created in here, it is created and stored in a symbol table. As I said to you, everything needed as text means macro variable is also nothing more than a text. So once the compilation is over, we can also execute our code. And execution of code is done by %test1. In here, test1 is the macro we have compiled earlier and we are executing. Here I have a semicolon. In here, we do not need a semicolon for execution. And this gives error. More on this error in a minute, but first let's look into our macro variables that are created. We wanted to create S and B, and we have used %put underscore user underscore to see our macro variables, how they are stored in symbol table. Now, when we do this %put underscore user underscore, this gives our results as something as I am showing below. Whenever we do %put and do something like underscore user underscore, we often see three parts to it. The first part is it tells the macro variable which it belongs to. Here, the macro variable S and B belong to test1 macro. And the second part is the macro variable itself. Third one is its value, how it is stored in symbol table. Here you can see that S is the value of proc print data SAS help dot class var name age run. Here there is something interesting in here. You can't see the semicolons and other special characters in here because all of them are masked. What does this tell us is %str has worked and it has created our macro variable, and also it has masked all the special characters. Now we do not see any value for another macro variable which we are created by using %b code. And let's see what is happening in here, why we do not have any value for here. The error we are seeing comes from this %let statement. If you look into the error itself, it says that expected close parenthesis after macro invocation not found. So the error is saying that It expected some close parenthesis, but it was not able to find one. This sounds little weird, but let's try to understand what it is exactly trying to say. Now, as I said to you, %b quote is not a compile time quoting function, so it does not work while we are compiling. So when we apply %b quote, what is happening in here is this semicolon is not masked. So %let statement thinks that everything has ended here and it doesn't go much further to see anything in here, because of which this closed parenthesis is ignored. So we have an open parenthesis, %let statement has ended here. We do not have a closed parenthesis, and that is what this error is all about. And because of this, the macro variable itself is not created. Now we have looked into compile time functionality in a detailed manner. Now let us also quickly try to understand about runtime functionality. Now again, to understand this runtime macro quoting function, let's try to understand it through an example in here. In here, I'm creating a macro variable in my data step wherein I'm using a call SYMPUT and I'm saying macvar in quotes followed by comma and variable. What I'm trying to do is I'm trying to take this variable value into my macro variable. Now I will explain you the runtime functionality with the help of two macros. The first one is macro test3 and second one is macro test4. In test4 I am using %str, whereas in test3 I am using %b quote. Before going into the details, again I want to remind you that %b quote is a runtime macro quoting function, %str is compile time macro quoting function. Now let me explain things through test4 macro. In here, what I'm trying to do here is I'm trying to use my %if statement and trying to compare this macvar value with another text. The macro variable, as I said to you, is nothing more than a text. So what happening in here is when I run this macro, that is during compilation phase, what happens is these %if, %then statements are checked for syntax, and as we do not have any macro variables to be created, nothing else happens in the compilation phase. And when I execute this macro %test4, what happens is this becomes %if, and here I have a caret symbol as my macro variable. Here what happens is %if caret symbol equal to j, then %put ampersand macvar, %else %put ampersand macvar. So what is happening in here is this %if and this caret symbol, once it resolves, equal to j it will become. So caret generally means a not symbol. So whole of this thing becomes not equal to j. But if you look into, there is nothing to compare in here. So it thinks that I'm saying %if not equal to j and then do something here or else do here. So what I wanted to be compared as a text is becoming a problem for me, because here it is picked up as a symbol and it becomes not equal to j, but there is nothing to compare over here, so I get an error. This is because While executing this macro, only this functionality works. And while executing, %str will not work because it works only during compilation phase. Again, during compilation phase, two things generally happen, that is checking of macro syntax, and also if there are any macro variables, they are created. Nothing of that sort is there during compilation. Only during execution we are having a problem, because during execution this not equal to or caret symbol is treated as a symbol rather than text. Now I have the same code in here, but now I have %b code. Now again we compile. There is not much to do during compilation phase. There are no macro variables to be created and nothing to be done of that sort, and only the syntax is checked. While executing, that is, my runtime functionality comes into picture. This %b code, what it does is it masks this special character during execution phase, or we can say while this macro variable is getting resolved. And this helps us to compare this caret symbol as text with the value or text j. As they are not equal to, this %l statement works, and then what it does is it puts this value of macro variable equal to ampersand macvar in the log, and you can see the same result in here. To sum it up, we can say that compile time macro quoting functions generally work during compilation phase, whereas runtime macro quoting function generally work during execution of the macro or while resolving of macro variable. And in here I want to add one more point, that is runtime macro functions work pretty late, whereas compile time functions are applied as early as possible. Now that we have understood about compile time and runtime, and we also have looked into special characters, now let us quickly focus on mnemonic operators. This is not very different than special characters, but I just wanted to deal with this topic so that it looks complete. Now in here I have a macro in here. In this macro, what I'm doing is I'm saying %if ampersand state equal to ny, then %put this is ny state, else %put ampersand state. Here in this macro I also have a parameter wherein I am saying state equal to. If I pass state equal to or during my execution, what happens in here is or can be treated as an operator. That is, when or is treated as an operator, what happens in here is this code becomes %if or equal to ny. This or is treated as a regular or operator. So after %if, we are directly going to or, and there is nothing to compare in here because this or is an operator. That's why we get an error. So this or, which is treated as mnemonics, if we do a %b code while executing, what happens is this or is masked and it will be treated as text, and now we are comparing or equal to ny as text. Actually or means Oregon, and now what we are doing is we are comparing text or with ny because of %b code doing the masking. Now as this is not equal to, this else statement runs. Again, this is something we have earlier seen also. It is just that now we are talking about mnemonics. Now let us talk about NR coding functions. NR here means no rescan or no resolve. Again, we have three types of NR functions. The first one is %NRSTR. It masks all the special characters along with percent and ampersand, and this is a compile time function. So you can think this as an extension of %str, and runtime NR functions are of two types. The first one is NRB quote, another is %superq. Here again, these are not the only ones. I am just discussing what I feel are important. In here, we are talking about %NRB quote and %superq. NRB quote is kind of extension of %B quote, and superq is a little different, and both of these are runtime quoting functions, that too NR quoting functions. These three NR macro quoting functions are very different, and the way they work is also different. So I would like to discuss each one of them separately. And also I want you to remember one important point. This %NRSTR, %NRB quote or %superq mostly we use when we want to mask percent or ampersand symbols. In here, I want to tell one another thing. For most of the examples which precede now, I will be discussing only for ampersand symbol. First, let's start with %NRSTR. Again, the important point here to remember is how these three are different. And I'm not going to talk about compile time functionality and runtime functionality. We have gone into that in much larger detail. But the focus is mainly on how these three are very different and how we can use them as per our requirement. Now, first let's start with %NRSTR. And this we can do with the help of an example. In this example in here, I am using a title, and in here I am saying quotes. This is %NRSTR and then open parenthesis, ampersand sysdate, close parenthesis, and then quotes, semicolon, and I have my proc print statement. In here, once I run this whole of this code, what happens is the result will be shown as follows. Here we have our proc print result, and also you can see that our title is this is ampersand sysdate. If you remember, ampersand sysdate is a automatic macro variable which is system date in date7 format. And %NRSTR, what it does is it masks this ampersand immediately so that this value is never resolved. That means this macro variable is never resolved because this ampersand is immediately masked. So that is the reason we see the value or the title as this is ampersand sysdate. So this is the important thing to know about %NRSTR, that is macro quoting is applied immediately and no macro variable is ever resolved. And now let us look into one example where this can be useful for us. Again, I have same proc print, and here my title says this class consists of boys, and in here I am using %NRSTR on ampersand girls. In here actually I do not have macro variable girls, and I am applying %NRSTR. If I don't apply %NRSTR, the macro processor will look into this macro variable and will give us a warning saying that girls macro variable was not found. And by applying %NRSTR, this ampersand is masked immediately, and this value of macro variable is never looked upon, and we do not have any warning. Now let us look into %nrb quote. %nrb quote is a runtime macro quoting function, and it tries to resolve ampersand and percent once, then it masks the resolved value. Now let's look into an example to understand this better. In here I am doing a percent put with a bunch of text, and then I am using %nrb code, and then I am using it on ampersand sysdate. And when I run this piece of code, this is what I see in the log. In here you can see that ampersand sysdate has resolved. And now the macro quoting function is applied on the resolved value. Now I would want you to understand the difference between %nrstr and %nrb quote. Here the main difference is %nrstr is applied immediately and masks this ampersand immediately. So this value never resolves. So whenever I say the quoting function is applied and masking is done, what is really happening is we are masking the special characters and making them to be treated as text rather than special characters. In here, ampersand is a macro trigger, and what we are trying to do here is we are telling macro system that this is not a ampersand, it's a plain text, don't treat this as macro trigger. And that is what %nrstr is doing immediately, whereas in the case of nrb code the masking happens after the value is resolved. Now let us look into one last macro quoting function, that is %superq. This is a runtime macro quoting function, and this also masks percent and ampersand. And here one important thing to know is it masks the macro variable reference within a specified macro variable. What does this sentence means? We will look into it in a minute. But first let us see how we are going to use superq. Here I am creating a macro variable using call SYMPUT, wherein we have created macro variable myMacVar, and it has a value of hello world. Here I am using %put %superq myMacVar, and then once I run this, this is what I see in the log. Now this looks very similar to NRB code, but I want you to look into one important thing is whenever we use %superq, we are not going to use ampersand. So we are referencing our macro variable without ampersand. That is the speciality of %superq. That is the first specialty of superq. Whenever you want to use %superq, we are not going to use any ampersand on the macro variable. And in here, as we have used %superq, the macro variable value got resolved. So we get an impression that this is very similar to %nrb code, but it is not, and let's look ahead to understand it more. Now I'm again creating a macro variable, and in here I'm doing call SYMPUT, and I'm creating a macro variable macvar, and it has the value of Tom, ampersand Jerry. Ampersand in general means and for us, right? But once I do %put %superq macvar and run this %put statement, what will happen is we will see Tom and Jerry. What is the great thing about this? In here we do not have Jerry as macro variable, and as I said to you earlier in the definition, that it masks macro variable reference within a specified macro variable, which means it masks this ampersand within the macro variable. we have Tom and Jerry as the value, so it marks this ampersand, and when we run this we do not get any warning saying that the Jerry macro variable was not there. So it masks this value. Now let us try to compare with %nrb code and try to understand this little bit more. In here again I am creating a macro variable, and this macro variable is word, and the value it will have is Ben and Jerry, and I'm using %put %nrb code ampersand word. Then what happens in here is whenever I run this %nrb code, as I said to you, it tries to resolve ampersands at least once. So what happens is it looks into macro processor and it tries to find whether there is an ampersand Jerry or not, and it gives as a warning apparent symbolic reference Jerry not resolved. Whereas in the case of %put %superq and word, what happens is we get the value of Ben and Jerry in the log, but we do not have a warning. Why don't we have a warning? Because %superq will not look into macro variable reference within a macro variable. Now this is an important thing to remember. So if we have to sum it up between %nrb code, %nrstr and %superq, we can think of this as follows. %nrstr macro variable is never resolved. Whereas in the case of %nrb code, all the macro variable references will be resolved and the masking happens on the resolved value. So everything is resolved once at least. Whereas in the case of superq, it resolves only the macro variable. Any ampersand references within the macro variable are not resolved. Now let us enhance this comparison of %superq with nrb code, and then we will finish this topic. In here I have %let Jerry equal to Jamin. Means I am creating a new variable Jerry and it has Jamin. Again I have same data step wherein I am creating my macro variable word and the macro variable is Ben and Jerry. In here I am using %put %nrb code ampersand word. What happens is, as nrb code always try to resolve ampersands at least once, what it does is first it resolves to Ben and Jerry, and as ampersand Jerry has a macro variable in here which has the value of Jamin, so it becomes Benjamin. Whereas in the case of %superq, it resolves to Ben and Jerry, and as I said to you earlier, it doesn't look into macro variable reference which is defined within a macro variable, so nothing happens in here. I know I have gone into a very long video for just macro coding, but believe me, I have just scratched the surface and there is more to this topic than what I have discussed. But these fundamentals will help you to understand macro coding better. Now to prepare these slides, I have taken the help of couple of papers, and link for these papers I will give in the description below. That's all for this topic. Today we are going to discuss about SAS Macro Series Part 7B. If you remember, earlier we had Part 7A wherein we have discussed about macro coding functions. In Part 7B, we are going to discuss about evaluation functions, %sysfunc, and character-based macro functions. Now let us discuss about various types of macro functions. There are four types of macro functions. The first one, the quoting function, which I have mentioned in here, we have discussed in detail in our earlier videos. Now coming to evaluation functions, what these functions do is they give the numerical ability to a macro variable so that you can do calculations with macro variables. And the next one is character macro functions. These are very similar to regular SAS character functions, but these are macro functions. And the next one is, by using %sysfunc, we can use data step functions itself as macro functions. About each of these functions we will go in detail in coming slides. First, let us start with evaluation functions. Before going into the evaluation functions, we need to understand one important thing, or I would like to reiterate one important point in here. Everything and anything in a macro variable is a text. I have been repeating this up to a number of times, but I think this is a very important point to remember. So that's why I repeat it over and over again. So whenever we are going to create a macro variable, in here I am saying %let a equal to 10 plus 2. Everything in here is text. None of them is treated as a number or anything else but as text. So when we want to do a %put and we want to look into the value of macro variable, what we will get is we will get a equal to 10 plus 2. And again, I have discussed about %put ampersand equal to macro variable in my earlier videos. Please have a look into if this is something new to you. But in short, whenever we want to do a %put, we can do ampersand equal to, and this will show the result in the log as a equal to and the macro variable value. Here the macro variable value is 10 plus 2. But what if we want to do some kind of calculation in here? Then we are going to do one thing, that is we are going to tell that please treat these values as numbers and this as a mnemonic operator wherein you can do plus in here. So this %eval tells the macro system to treat these values as number and this as the operator, and then when we do %put ampersand equal to b, we get the value of 12. Not only plus, we can do other things also. In here I am doing %eval 10 multiplied by 2, and this gives the value of our macro variable c to be 20. So %eval gives the ability to do some calculations. In here we have explicitly used %eval and we were able to do some kind of calculation in here. Actually, there is one important point to remember is not every time we have to use %eval, but some of the conversions happen automatically. Now let us look into an example for that, and this is known as implicit or implied %eval. About this I have discussed in one of my earlier videos, and link for the same I will give in the description below. But let's also quickly try to understand what is meant by implied %eval. In here I have a macro. In this macro I am defining my macro variable %let z equal to 2, and also I am doing a %do loop in here wherein I am saying I equal to ampersand z plus 2 %2 10 plus ampersand z %by ampersand z, and I am also saying to put the value of this macro variable in here, and then I am ending this do loop in here, and finally I am ending my macro in here by using %ment. Before going into any other details, now let us try to understand what is happening in this %do loop. In this %do loop, we are creating a macro variable I, and in here we are saying ampersand z plus 2, which is our starting point, and we are saying our ending point as 10 plus 2, and also we are saying that to increment by 2 because our macro variable z has a value of 2, and we are also trying to put the value of this macro variable I after every iteration, and then this loop ends when it reaches this endpoint. Now let's compile this macro by running the code from %macro to mend the macro by running %ys, and after executing the macro, this is the result we see in the log. Now let's try to understand what we see in the log in here, and in here you can see that the value of I is 4. What does this mean is this ampersand z plus 2 became 4, and the starting point is 4, and we are doing a %put, that's why we have 4. And once this iteration is completed, in the second iteration it increments by 2 and becomes 6, and then again increments by 2, 8, and then again increments by 2, 10, and again one last time it increments and comes to 12, and 12 is our endpoint in here. So what I wanted to tell you in the whole of this thing is, even though we are doing addition here without %eval, the addition is happening. And this is known as implicit or implied %eval. Here I want to tell you one thing. That is, even though we have not used %eval, in certain scenarios, the %eval runs behind the scenes and it does all the calculations. And this is the one of the scenario which I am showing you in here. Now let us quickly move on to another topic. Even though %eval is very useful in giving numeric ability to the macro variables, it has its own limitation. Especially it is very limited when we are trying to use any macro variables which have decimals. Now let us look into an example and try to understand it better. Here I am saying %let a equal to 10, and then herein I am doing %put ampersand a plus 1.2, and I'm also doing %put %eval ampersand a plus 1.2. Here ampersand a plus 1.2 gives 10 plus 1.2, that is our ampersand a gets resolved to 10, and then we have 1.2, and we also have the plus symbol in here. Here it is a simple straightforward macro variable property. But when we are trying to do a %eval and then trying to do the calculation, we get an error saying that a character operand was found in %eval or %if condition 10 plus 1.2. So it has a problem with this decimal. Now to address this, what we can simply do is we can use %syseval f. And when we do %syseval f and then we say ampersand a plus 1.2, it gives us 11.2. Now we have discussed our evaluation functions. Now let us move forward with character-based macro functions. Character-based or text-based macro functions are very similar to data step functions, but they work on macro variables and text. Now let us look into an example and let's try to understand what is different in here. So first let's try to create a macro variable. In here I am saying %let n equal to hello world, and I am doing a %put and I am saying value is at, and in here I am using my %index function. This is very similar to index function what we use in data step. And in this function my first argument is my macro variable ampersand n, and then followed by comma, and my second argument is world. That is, I want to find the location of world in this macro variable. Obviously the macro variable value is hello world, and we are trying to find where world is. There are two different between macro functions and also our regular data step functions, especially related to character based functions. The first one is pretty obvious, that is whenever we used macro functions we use a percent symbol in front of the function. And the second one is more important and subtle. That is, whenever we are trying to do an index function in the data step, when we have two arguments, the first argument, what we do is we usually use our variable, and the second argument, what we do is we use some kind of character value and we put them in the quotes. And when we compare that to our percent index function, we again have two arguments. Here the first argument is generally macro variable, and the second argument here will be a text. We don't put any quotes in front of it because we are searching for this particular text in this macro variable. And if we try to put quotes in here, what happens is this will try to search the word along with the quotes and it will never find it. So an important thing to remember here is we are trying to check for a text in here. And I think instead of telling character based macro functions, I should have probably used the word text based macro function. Now, after this, let's look into what happens to our result. It finds the word world at the 7th position. This is again very similar to our data step index function, but we are using on macro variables and comparing with the text. Now let us discuss another aspect of macro functions. For every regular macro function, there is a quoting macro function related to it. Now let us try to understand this through an example. And for this example, let us take percent upcase. To understand percent upcase, let's create a macro variable. In here I am saying percent let h equal to my world. And in here I am doing a percent put and using a percent upcase on this macro variable h. And you can see here that in the result we have my world upcased. That is, by using percent upcase we were able to upcase the value of macro variable, and there is nothing special about this. Now to understand Q functions, let's get into another example. In here I am creating three macro variable A, B and C, and for A we have the value of test and for the B we have the value of semicolon. To pick up the value of semicolon into the macro variable we need to use %str. I have discussed in lot detail in my earlier video about %str and how quoting functions work. And now also I have another macro variable C equal to hello. Now after creating these three macro variables, I want to do upcase all these three macro variables. Before going into the details of this %upcase, please check out my video on quoting functions wherein I discuss about %str in detail, and link for the same I will give in the description below. And another thing is, if we would have not used %str here for the semicolon, what would have happened is this %let would have ended here. That is where the semicolon is there. And what would have happened is it would have had no value in here. But for this macro variable B, we want the value of semicolon. So this %str, what it does is it helps to treat this semicolon as text. Now let's get into our %upcase. In here I am doing %upcase on three macro variables together at one time. And what I am doing here is I am saying %upcase, and in the parenthesis I have &A, &B and &C. Once we run this %put statement, this is the result we see in the log. In here we see that &A value test is upcased and also &C value hello is upcased. But we also see an error. The error at this point is because whenever we are starting our percent put statement, it ends with a semicolon. Because ampersand b is semicolon, our put statement ends in here, and hello seems to be something which is not related to this percent put statement. That is why we have an error in here. To avoid this kind of error, all we need to use is percent %q upcase. What this does is it does upcase and also it does quoting. And because of this quoting, it masks the semicolon and the semicolon is treated as text. And when we do this percent put now, we don't see any error in here. Regarding the quoting functions, I have made a very long video of close to 45 minutes, and link for the same I will give in the description below. Now let us look into the last topic, that is using data step functions with the help of %sysfunc. We can use most of the data step functions with the help of %sysfunc, except very few like input function, put function, lag function and others. Now let us look into some examples to understand this better. In here I am creating a macro variable %let name equal to smith.john. I want to create another macro variable x, and what I want to do is I want to have the macro variable value of name, that is smith.john, but I also want this dot to be changed to underscore. Transvert function is one function in data step which locates a particular character and it replaces that particular character with another character. We can use the transvert function in this %let statement by simply using a %sysfunc followed by our transvert function. In here we are saying %sysfunc and we are starting a parenthesis, and then we have our transvert function. For this transvert function we have again a parenthesis, and then we have our three arguments, and this parenthesis is closed, and this is for our transvert. These three arguments are nothing more than, first is macro variable, the second one is the character we want to replace, and the third argument is what is the character we want this to be replaced with. We want to replace dot with underscore, so here we have dot and here we have underscore, and finally we close with another parenthesis for this %sysfunc. If you remember simple data step functions, we have transvert and all of this set. Only new thing here we are doing is we are using %sysfunc, and then we are having a parenthesis start and parenthesis closed. In this fashion we are able to access transvert function from data step into our macro facility. Now another important thing to remember here is I do not have quotes around this dot or underscore because everything here I am dealing is with text. Here I am not dealing anything particular with character variables or anything. That's why we don't have any quotes here. If I have kept a quotes in here, what would have happened is this would have looked for in this particular macro variable for quotes and dot, and that is not what we want. And once we have created this macro variable, we can simply use %put statement and see the result, and the result we can see that result is smith_john. So %sysfunc is helping us to access data step functions very easily. Now we have used one of the character functions of data step. Now let us try to use one of numeric data step function. Again, pretty straightforward, pretty same. All here I am doing is I am creating three macro variables k1, k2, k3, and I am having the value of 10, 22 and 55. And what I want to do is I want to find a max value from these three macro variables, and I can simply do with the help of max function followed by my three macro variables which are my arguments for this max function. All again I need to do is I need to add a %sysfunc, parenthesis and close to the parenthesis. Now I am able to access the max function, and when I do the %put for this macro variable, I can see the value as 55. So In here, we are able to easily access numeric functions of data step also. Now let us go further ahead and try to understand how to nest these functions. We have done these kind of things in data step, or we do these kind of things in data step quite often, wherein we have to use more than one function on a particular scenario. In here, what I want to do is I want to do two things. The first thing is to find the max value within these three macro variables, and whatever the max value I get from these three macro variables, I want to do a mean, and that mean I want to do with a value of 10. So first I can simply do is percent sysfunc, and then max value I can find it out here like this. This we have seen before. And here, as we can find our max value by using percent sysfunc and the max function of data step, to do a mean is again also super simple. All we need to do is we need to modify very little bit. That is, we need to do one more percent sysfunc, and then I need to mention mean, and then I need to start a parenthesis 10 comma, and I need to have this percent sysfunc for max value. So this nested percent sysfunc on the max will give me the max value, and in this case it is 55. And once we have this value, the second percent sysfunc is applied and we get our result of mean, that is 32.5. So the important point I want to mention is this is very similar to data step, wherein we have to use multiple functions. What we simply do them is we nest them. We can also nest percent sysfuncs, and then we use our functions very similar to what we do in data step. Now let us look into what else we can do with our percent sysfunc. We can also apply formats by using putn and putc function. One another thing I want to remind you is we cannot use put function with percent sysfunc, but we can use putn and putc. Putn allows to apply numeric format, whereas putc allows to apply a character format. Now let us look an example for both of this. In here I am doing percent let c1 equal to 22281. This is a numeric value, even though this is a text, and we can apply a numeric format by doing a percent sysfunc followed by putn, and then we are using our macro variable c1 which we have created here, followed by our format, that is ddmmyy10 dot, and this is a numeric format. And we are also doing percent put to see this value in the log, and once we run these three lines of code, this is the value we see in here, that is 01012021. So by using percent sysfunc and putn, we were able to apply format to this value, and we have applied here numeric format. And also we can apply a character format also. To apply character format, we need to use putc. In here we have a macro variable b, and we are saying hi, how are you, as a part of this macro variable. We can do a percent put, and here what I'm doing is I'm using percent sysfunc put c, and then I'm applying this on macro variable b, and in here the format I'm using is uppercase 14 dot, and here you can see that once we run this piece of code, we have the value hi, how are you, and the value is uppercased. So we have applied the formats to display the data we want it to be. I'm not going to discuss about what is a format and any details about putn and putc, because we are majorly concerned about percent sysfunc and what it can do for us. If I go into the details of format and all those things, it will become a long video on itself. Now let us look into some informats. We can apply informats by using input n and input c function. And now let us look an example for both of this, that is for input n and input c. Here I am creating my macro variable b1 by saying %let b1 equal to 01 backward slash 01 backward slash 2021, and then I am creating another macro variable and wherein I am saying %let b2 equal to %sysfunc, and I am applying here input n in format, and here I am using my macro variable as my first argument, and in here I am applying my in format. And once I apply this in format and create this macro variable and use a %put, and once I run all of this code, I see the value as 22281. Now here we have used in format. In formats are mostly to read the data. Formats are to display the data. I don't want to go into details of this, but if you want to do something and want to change the macro variable appears, you can do it. You don't have to go to data step and do it, but simply you can use %sysfunc and use put n, put c, or input n. Now let's also look into one example of input c. Input c allows us to apply character in format. In here I have macro variable %let a equal to quotes hello world and quotes close semicolon. And what here I am doing is I am doing a %put, and here I am using %sysfunc. Followed by it I am using input c and applying a character in format, and in here I am saying $12 dot, and my first argument is the macro variable a. And once I run these two lines of code, I see hello world. If you see, we have started with double quotes around, and by using this particular in format, now we have hello world without having any quotes. So I have gone through briefly on formats and in formats and how you can change the values of your macro variables with the help of them. Now let us go ahead and look into one application of this %sysfunc, and I will also discuss about a quoting sysfunc, and then we will wrap up this topic. In here I have a macro. What this macro does is we are trying to see whether a particular file exists or not. If it exists, we want to read it with the help of proc import and create a data set. If the file itself is not there, then what we want to do is we want to say that the particular file is not there. And in here we have a parameter that is our file name parameter. What we will do is whatever file we want to check, we can just pass it as parameters. Again, we can do all of this with the help of %sysfunc. Here I am writing %if %sysfunc, and in here we are using a data step function file exists on macro variable file nm, and then I am closing my parenthesis %then do, and in here we are doing two things. The first thing is we are giving a file name statement which is as follows: file name followed by a file ref and the location of the file in the parenthesis. As I said to you, this file comes from our macro variable, and that macro variable is file nm. And once we have used this file name statement, this file ref we are using in the proc import, and in here we are also creating a data set. And this part ends here with the %end. If we do not have the file here, we are saying else %do %put this file ampersand file name does not exist %end %ment. So once we compile this macro, we can execute this macro by saying %file checking and then passing our file name in here. And if you see in here, the dataset was created because this particular file was there. And in the same macro, if you pass a file name which is not there, we are going to get the message that this particular file does not exist. With the help of %sysfunc, we were able to use datastep function file exist, and also by creating a macro, we were able to automate a process. This process, what it does is, it checks whether there is a particular file or not, and if it is there, it will create a dataset. If it is not there, it will tell us that particular file is not there. And now let's look into our last topic, that is %q sysfunc. And we can understand this with another example. In here, I am creating a macro variable wherein I am saying %let x equal to %nrstr, and then in here I am having %proc a, %proc b. If I do not use %nrstr, I may get a warning saying that %proc a and %proc b macros were not there. And now what I want to do is, I want to use %sysfunc and datastep function substr and want to extract something from this particular text. What I want to extract is %proc a. So what I am saying is %sysfunc substr, and then I'm using this macro variable itself, and then I'm saying that to extract starting from 1 position to 6th position. So what it does is, it extracts this particular value. But when we run these 2 lines of code, we also get a warning. This warning says that apparent invocation of macro proc a not resolved, means it is looking for macro proc a, because whenever we execute macro, we simply give a % and macro name. To avoid this kind of thing, all we need to do is, we need to use %q sysfunc just instead of sysfunc, and then we can use our substr and %x, 1, 6. And when we run these 2 lines of code, now we are not going to see any error, but we are going to see the value of %proc a in the log. In here, what I wanted to tell is, whenever we use datastep function and sysfunc, and if we feel that we have some special characters and we need to mask them, we can simply use qsysfunc. And in here, I'm not going to go into any details regarding how quoting works and what quoting does, but I have made a very long video on that, and link for the same I will give in the description below. That's all for this topic. Today's topic is about macro libraries, and this is part 8 of our SAS macro series. First, let us try to understand what SAS macro library is and what kind of SAS macro libraries are available for us. Before going into those details, first let's try to understand why we need a macro library. Till now, the major focus was how to write a macro and other nuances related to this macro code. But it is very important to know how to store this code or our macro. The reason being, whenever we are writing macro, the intention is that one person creates or one programmer creates the macro, and many people or many programmers will use this macro code. To use this macro code in such a way, we need to either store the macro or macro code in one location, and all others can use from that particular location. There are 2 main advantages of this approach. The first one is ease of use. One programmer builds the program and everybody can use that program or macro. Another advantage is it avoids copying the macro code into each programmer's program separately. whenever macro program is copied into separate programs, what could happen is the programmer could change the code according to his or her wish, and then what finally will happen is we will have a different copies of same macro, but the macro itself might have been modified a whole lot, and this kind of thing is not good in any organization. There are three ways to create macro library. The first one is %include. %include is nothing more than pointer to our code. And the second one is SAS stored compiled macros, wherein we compile macros and store in a particular location. The next one is autocall library, and this is very similar to %include, but it is little different than %include. We will discuss all those in upcoming slides. Now let us try to understand %include. As I was earlier saying, %include is nothing more than a pointer to code. To understand this, let us look into one of .sas file in here. In here, I have one of my .sas file wherein I am saying it's test1.sas. Let me click on this one. Once we click on this one, we can see that I have a macro in here wherein I am saying macro pp, and then I am also saying proc print data equal to sashelp.cars and then run %mint. I do not have any parameters. I just made a very simple macro in here. And I have saved this code in this particular location sometime back just to illustrate whole of this. Now let me close this, and let me also right click on this and see where is the location. The location of this file is in this particular location. And if you see in here, I have also have my %include statement, and I have given the exact path in here. Now by doing this, what I am doing is I can access my macro which is stored in here. Now let us quickly run this %include statement. Once I run this %include statement, my macro will be compiled. And I can execute this macro by giving macro name, and before the macro name all I need to do is I need to put %. And in here I can execute my macro by saying %pp, and once I run it, it will do my proc print of sashelp.cars. If you remember, our macro is nothing more than code related to sashelp.cars. Now let me again close this. Not only this is the one way to do a %include, we can also do %include with the help of file ref. What is meant by file ref? File ref is nothing more than, it is another pointer wherein I am saying file name and we give file ref followed by path. Whenever I want to use this path, instead of writing my path, I can just give this file ref. So whenever I say this file ref, it means this particular location. Now I can do a %include and I can use this file ref. When I'm using the file ref my file, this means I'm using or I'm accessing this particular path. So our include becomes, or our %include becomes %include and this whole of this path. In here I have a different file, that is test2.sas. Let's look into test2.sas real quick. In test2.sas I have a macro which is known as PM, and I have a parameter dsn equal to, and in here I have proc means data equal to ampersand dsn run, and then I'm closing my macro with %mint. Whenever I say test2.sas means I'm just telling about the relative path, but what I mean is whole of this path which I can get by clicking on the properties. That is what I mean by test2.sas means the whole of this path. Now once I have run this particular code, what it does, it compiles my macro, and now I can access my macro by simply doing my macro name followed by passing the parameter. Here I want to pass sashelp.class. and here you can see that it does the proc means. And here what I wanted to tell is, now I want to tell one important thing in here. Percent include is just not for macros. We can also use our regular code also. So percent include is not very specific to macros, but we can use it also for macros. Now in here I have another folder wherein I have said my new folder 1, and in here I have ds.sas program in here, and in here I have a simple data step. This simple data step also I can execute through percent include. Now if I run this percent include, what it does is it immediately executes the code which is there in this ds.sas. That is our simple data step where we are doing a set statement and copying the data to another dataset class. There are a couple of other specialty related to percent include. Now in here if I look into test1.sas, I have only one macro. I need not have one macro. I can have 10 macros in this particular .sas file. This is something special about percent include. And when we do a percent include for this test1.sas, if I have multiple macros in it, what will happen is all the macros will be compiled. And not only I can have many macros in this particular .sas file, but I can also include some other code also in here. Like I can have my proc print, or I can have my data step, something which is not even related to macro also I can keep it in a file, especially in this particular file. So what you need to understand is percent include is just not meant for macros only, but you can use it for other purposes also. That is, you can keep your other code also in here. Whenever you have macro, when we use percent include, the code will be compiled, and if you have a general code, what will happen is it will be executed immediately, as I have shown you earlier in the case of this data step. Now we have looked into a lot more detail for percent include. Now let us look into the next topic, that is SAS stored compiled macros. Now let us quickly try to understand what happens during macro compilation. I'm not going to provide any details regarding macro compilation because I have made a very extensive video on the same topic, and link for the same I will give in the description below. But once our macro compilation is successful, a macro will be stored in macro catalog. And by default, this catalog is in work library. And in here, this catalog name is known as SAS MAC1. As I'm using SAS Studio, it is SAS MAC1. For others, it could be SAS MACR. For others, it could have a different catalog name. Now, if I run a proc catalog and say proc catalog equal to work.sas mac1 semicolon content semicolon run semicolon and quit semicolon, I can find what all macros which are compiled are available to me. In here you can see that I have close to 6 macros in here. I have just taken the partial print of this one and kept it in here. The first 4 are by default created by SAS Studio and is not related to this topic, but the other 2 macros, PM and PP, are the macros which we have just created, and they have been stored in this particular location. The problem with work.sas mac1 is these macros are there only for a particular session. Once we restart our session or once we end our SAS session, these macros will not be there. So they have to be compiled again. To avoid this recompilation over and over again, whenever we need a macro, what we can simply do is we can store this compiled macro, and this concept is known as stored compiled macro facility. or we can simply say stored compiled macro. To store a compiled macro, we need three things. The first thing is we need to do a libname statement wherein we have to give libname, libref, and we need to give the path. Why we are doing this is we want to store our macro to this particular location. So we have to state the libname. And we also need to give an options wherein we need to say options mstored SAS mstore equal to this libref which we have defined in here. So what we're trying to tell here is whatever the macro we are going to store, please store it in here. And we are telling that that store is this libref which is pointed to this location. And whenever we run the macro, we need to say after the macro name /store. And when we do all of these things, what happens is this macro will be compiled and it is stored in this particular location. Now let us quickly run libname, these options, and also this first macro. Everything in the log seems clean and also our libname has worked fine. Now let us quickly go ahead and run the proc catalog in here wherein I am saying proc catalog equal to myslib.sasmacr. So I'm interested to look into the catalog which is there in myslib. Myslib is nothing more than this particular location where we have stored our macro. Now let's quickly run this and see the result. And once I run this, I see the result that this particular macro is there in this particular location. Whenever I say or whenever anybody says libname, he is directly telling that it is pointed to a particular location. In our case, that location is this one. So we have stored our macro. Now you have seen that how we can compile a macro and store in one particular location. Now let us say I don't have this code anymore, but I only have the stored compiled macro. How can I retrieve the code? This can be easily done, but before doing that I want to show you something interesting. I have another macro. Again it is the same like this first macro, but all I am doing is I am adding one more option after store, that is source. And once I compile this macro is stored. Because I have this option source, I can retrieve the code also. Code retrieval is pretty simple and it can be done in many ways, and whatever the way suits you, you can do in that particular way. And in here, what I want to show here is, once let's quickly run proc catalog to see our macro 2 also. Here we have our macro 2 also. Let us quickly remove all the code in here, and we do not have any code in here now. And here what I wanted to show you is, see, I have compiled my macro, but I do not have the code related to it, or I forgot to save it. Now how can I retrieve the code? As I have already used the word source, I can do a %copy and write my macro name followed by /source. Whenever I do this, it will write the code to the log. Now let me quickly run this. Now the macro 2 is written to log. Now here we simply wanted to do a copy of this macro 2 to the log. Not only that, what I can do is I can also copy this particular code to a particular location also. To copy the code of macro to a particular .sas file is also straightforward. All we need to do is we need to write %copy followed by macro name /source, and then we need to mention lib equal to whatever the library from which we are copying. Here it is my slib, which we have defined earlier, in which our macro resides. Rather, I would say our compiled macro resides, and then out equal to the location we want to write that particular .sas file. In here I want to write to this particular location and my file name is jkl.sas. Now let us quickly run this piece of code and then see what happens. And once I run this code, you can see that there is a new .sas file in here, and in here it has the code related to macro 2. Now we have discussed in detail about stored compiled macros. Now let us quickly try to understand the significance of stored compiled macros. As I said to you, we can compile once and we can use it at a later point. To explain this point, let us refresh our session by clicking reload or refresh in here, and then now we are getting into a new session. Once we get into our new session, I need not compile this macro again, and what I just need to do is I need to define my libname, and then I need to also tell the options mstored SAS mstore equal to libref, which we have defined above. Now let us quickly run this libname and options mstored SAS mstore equal to. Now I can easily execute my macros in here. Now I am executing my one macro and gives the result. The important thing to know about in here is when compared to %include, whenever we run %include, the compilation happens again, and whenever you start another session and you do another %include, the compilation happens again. But in the case of stored compiled macros, this does not happen. Once you store the compiled macros, all you need to do is you need to give libname statement and options like this, and then you can execute the macro. One of the major challenges of stored compiled macros is we also store our code at one location, and we also store our compiled macro at another location. Often this causes confusion. Compilation of macro usually takes very less time. Usually it will be within seconds. So there is rarely any need of creating stored compiled macro. And from the discussions what I see in SAS communities, it is being said that stored compiled macros are hard to maintain also, especially when stored compiled macros have to be migrated. And the discussion regarding stored compiled macros in SAS communities, I will give the link in the description below. One last point about stored compiled macros, and this is from my experience. I have never seen a stored compiled macro in the real environment. And now let's get back to another important topic, that is autocall library. As explained to you before, autocall library is similar to %include, but we need to understand one important thing here. %include is just not for macros. We can write any SAS code and we can store and we can call with the help of %include. But in the case of autocall library, this is exclusively about SAS macros. Now there are many other differences, but this is the first difference which I want you to remember. Before telling about the differences with the %include, let's first discuss about autocall library itself. Autocall library is usually a folder or a directory which contains one or more .sas files, and this .sas file contain one macro in each file. Here I have my autolib, and this folder I'm going to treat as my autocall library. And in here I have two .sas files. The first one is known as test1.sas and second file is known as test2.sas. And each of these file has one macro in it. Now let me quickly click on each one of them. In here in test1.sas I have a macro. Again, this macro name and this file name should be same. Here it is test1.sas and my macro name is also test1, and I have only one macro. So very specific, unlike our %include. And now let me close this and let me open test2.sas. Here in test2.sas I have another macro, but only one macro, and this macro name is test2. That is, it has the same name of our .sas file. And now let us see what else I need to do to make this work. First we need to use a file name statement wherein I need to say file name followed by file ref and the location of that file. And here this is the location of our file, and in here you can see that I have the same location pasted in here. Now after that I also need to say options m auto source SAS autos equal to, and I need to mention this libref in here. Once I run these two lines of code, I can access all the macros which are there in this particular folder. Now let us quickly execute this test2 macro. And once I execute this test2 macro, you can see the result also. To conclude, by simply using file name and using the options m auto source SAS autos equal to file ref which we have mentioned above, we can access many macros. This is a very clean way of accessing many macros and giving access to many other users all these macros which we have kept in this autocall library. And in here I want you to look into one another important point, that is, after SAS autos equal to, I have mentioned a parenthesis and then I have given a libref and then I have closed parenthesis. I have done this to show one another thing, that is, if you have another file name, I can use that another file name also in here along with this, something like putting a comma and another file ref, I can put it in here. I do not want to go into details of that topic, but I just wanted to tell you that that particular option is there. Now that we have looked into all three of macro libraries, now let us discuss the final topic, that is order of macro search. What do I mean by order of macro search? When I'm trying to execute a particular macro, what it will see is, it will try to see where is the compiled macro available or in which location that compiled macro is there. First it looks into work.sas mac1 location. Then it goes and looks into stored compiled macro. Then finally it looks into autocall macro libraries location. And with this we have completed whole of this topic, but I would like to tell one another thing. To prepare whole of this presentation, I have taken the help from one of Art Carpenter's paper, and link for the same I will give in the description below. That's all for this topic. Today's topic is about macro facility interaction with the call execute. And this is part 9 of SAS Macro series. Now let us briefly look into call execute. Here I will give a very general introduction about call execute And more on this we will look into and try to understand with the help of code. Now call execute is a data step function. Call execute, what it does is it allows us to pass character string to macro facility for immediate execution during data step. This point is very important to know. Whenever we try to mix macro facility and data step, what will happen generally is macro facility generally runs first, and this is due to macro triggers ampersand and percent. And we have discussed in detail about this topic in the very first video of SAS Macro series, that is SAS Macro series introduction. Now what call execute does is call execute allows us to interact a data step with macros facility, and how this happens we will discuss in detail with the code. And now there is one another important point here is whenever there are SAS statements generated during call execute, they are stacked in input stack, which will run once the current data step completes. These 2 points are very important to know in the call execute. So most of the time the problem comes with the call execute is understanding the timing. With this brief introduction, let's try to look into the code and try to understand call execute more. Now let us try to understand call execute with a very simple example. In here I'm highlighting my example. In this example we do not have any macro reference. I have taken this simple example to explain how call execute works. In here, if you look into, we have a data step in which we are saying data underscore null underscore, and we are saying then call execute, and in the parenthesis we are having a code, and in this code we are writing proc print data equal to SAS help.class semicolon run semicolon, and then I'm closing my quote and also my parenthesis. And what will happen is once I run this code, it will generate a SAS statement. This SAS statement will be saved in input stack. And once the data step is completed, then only this SAS statement gets executed. Now let us try to quickly run this piece of code. And here we can see our result. This is not very important, but let's quickly go into the log. And in the log, if you see, we have our data step in here, and in here it shows that this data step is complete. And once this data step is complete, we can see a note wherein it says call execute generated line, and this line is nothing more than proc print data equal to SAS help.class semicolon run semicolon. And in here this particular statement was generated during data step, but it got executed only after data step is complete. And now let us try to understand this little bit more with the help of an example which is a little bit more useful to us. Here this is super simple, rarely we use this kind of thing for call execute. Now in here I have a data set. In this data set I have a variable, and the variable name is DSN, and I have three observations in here. The first one is SAS help.class, second one is SAS help.class, third one is SAS help.air. My goal here is to generate statement as follows: proc print data equal to SAS help.class semicolon run semicolon, and then I want to generate proc print data equal to SAS help.class semicolon run semicolon, and same with the SAS help.air. Now what we can do for this is simple. In here we are again using data step to generate the lines we want. And in here I am saying set P, that is from this data set wherein we have three observations. And in here what I am doing is using a set statement, I am saying set P. And also I'm doing a call execute. And I want you to focus here. This call execute which I have earlier discussed and this call execute is very similar except one change. Here what we are doing is I am directly writing SAS help.class and this generates this proc print statement, wherein what I am doing here is I am writing everything up till in here in quotes, and then for this part SAS help.class part, what I am doing is I am concatenating with DSN variable, and the DSN variable value comes from this data set, and the remaining semicolon to run semicolon again is the same, and again I am concatenating it with this DSN. So let's see what is happening in here. So when SAS reads the first observation, this DSN will become SAS help.class. Whole of this statement will become proc print data equal to SAS help.class semicolon run semicolon. This SAS statement will be generated and it will be stored. And then it reads SAS help.cars and this becomes proc print data equal to SAS help.cars semicolon run semicolon, and then again it reads the third observation and this does proc print data equal to SAS help.air run semicolon. And if you see in this fashion, we are reading each observation and then we are able to dynamically create SAS statements. Here, because we have three observations, we have created three proc prints, and one important thing to remember here is all of these three statements generated will be stored in the input stack. And one another important thing to remember is all of these three statements will be executed one after another once data step is complete. Now let us quickly try to run this and see what is happening in here. And let's quickly look into the log to understand this better, and what is happening exactly we can only know from the log. Here, if you see, first we have created our data set and everything was clean, and then we have run our call execute. If you see here, it shows that this data step is complete. If you see in here, we can see that the first SAS statement which was generated during data step got executed, and we can also see about it in the results in here. And also, once we go little bit down, we can see that the second SAS statement also has been executed, followed by the third SAS statements. We need to understand that the SAS statements got generated during data step, and once the data step is complete, all the SAS statements which were in the input stack execute one after another. Now, till now we have seen what happens when SAS statements are generated during call execute. But now let us quickly look into what really happens when no SAS statements are generated during data step. Here I have a data step wherein I am saying data underscore null underscore, and in here I have set SAS help.class. And in the call execute, what I am doing is I am doing %put and name is in single quotes. The important point I want you to remember is I have kept the whole of this thing in single quotes. Why is this important? If I have put this in the double quotes, what would have happened is this %put would have executed even before the data step starts, because these percent and ampersand are macro triggers, and when they are in double quotes they execute immediately. So what will happen is this step executes immediately even before reading anything from SAS help.class. Now let us see how this whole thing works. In here, as I have written percent put name is in single quotes, and I'm concatenating it with name variable which is there in SAS class. First, what will happen is the first observation in the SAS class will be read, and the name variable has the value of Alfred here, and the text in here will become percent put name is Alfred. And if you can see in here, there is no SAS statement in here. When I say SAS statement like proc print or any data step, there is nothing of that sort. So what will happen is this will execute immediately. So this percent put will put the value of name is Alfred into the log, and then what will happen is it will read the second observation. The second observation, I know the value of variable name is Alice. So what will happen in here is the same thing which we have seen before, and this puts the value of name is Alice into the log. And if you can see in here in the same fashion, it will be reading each and every observation in SAS class, and it will get executed immediately. And now let us quickly run this and see what happens in here. In the note here you can see that call execute routine executed successfully, but no SAS statements were generated. This you can generally see after our data step completion. But if you see in here closely, all our put statements, or rather I would say percent put statements, have been executed, and they are here, they are well before our data step completion. For example, if I would have added another call execute, and in that call execute, if I would have added something which creates SAS statements, then what would have happened is I would have had these values in here and all the SAS statements after my data step completion, but I have not done that to keep it simple. The important point to remember is call execute executes immediately when there is no SAS statement. But if there are SAS statements, what will happen is they are stacked up and they are kept in input stack, and once the data step is complete, all of those SAS statements get executed. So there is a timing difference when there is SAS statement created and when there is no SAS statement created. Till now, we have been looking and trying to understand how the call execute works. But till now, we have not tried to look into how call execute interacts with the macro facility. Now let us look into that aspect. To understand this concept, what we need to do is we need to look into an example. Now, to understand this example, let's quickly look into this data step. But before the data step, I would like to explain what we want to do in here. In here, the target is to create data set from each name in SAS help.class. So I want to create a data set from each name in SAS help.class. One way to do it is write something like this: data Alfred set SAS help.class where name equal to in quotes Alfred semicolon run semicolon, and this creates Alfred dataset. And to create Alice dataset, all I need to do is I need to change in here and also where name equal to Alice. Instead of writing all of these 19 names in here and here to create 19 datasets from SAS help.class. Why I'm saying 19 dataset is I know that SAS help.class has 19 different names and we can create 19 datasets. Instead of that, we can create a simple macro, something like this, wherein I am writing percent macro test, and in the parenthesis I am writing nm equal to, and then in here what I'm doing is I'm mentioning data ampersand nm set SAS class where name equal to ampersand nm in the double quotes, run semicolon, and then I'm closing this macro. So once we create this macro, what I can do is I can pass Alfred, Elise, and each name. But the problem with this kind of approach is I have to pass each name. Even though I'm not writing a lot of code again and again and again to create data sets, but I have to pass parameters over and over again. And this is not efficient. And this kind of problems are more easily solved in a dynamic fashion, wherein we do not pass parameters but we bring it from a data set. This kind of things can be solved by using proc SQL into clause and also followed by a %do loop in a macro, or by using call SYMPUT and then using a %do loop. And I have discussed about how to do that in one of my videos of proc SQL into clause, and link for the same I will give in the description below. But whenever we want to do those kind of things, the code becomes little bit more complex. That is, first we have to create macro variables and then we have to use do loops. But these kind of things can be easily solved using call execute. Now let us see how we can do this thing using call execute. Now in here what I am trying to do here is I am having my data step wherein I am using a set statement and I am mentioning SAS help.class. And in here if you see what we are doing is we are using call execute. And this call execute is going to generate these macro calls. And how is that happening is in the single quote I'm using %test, which is very similar to this, and also I'm using parenthesis and name equal to in here in quotes, very similar to what we have in here. The Alfred comes from this SAS help class when we read the first observation, and then I'm also adding this ending parenthesis with the help of concatenation, and then I'm adding this part. So in a way I'm generating this statement. In the same fashion, after reading each observation, we are going to change our parameter and generate this statement. And in here important thing to remember here is this macro has a SAS statement. So this gets executed only after data step is complete. And to understand this, now let us quickly try to compile this macro. And now let us also quickly run this data step which is called execute. And in here you can see that 19 data sets were created. And let's also quickly look into the log to understand this better. In here you can see that our data step is complete in here. After the data step is completed, you can see that call execute has executed first SAS statement which was created during data step, that is this one. And after that it has executed second SAS statement which was created. So here you can also see the numbers 1, 2. In that fashion you can see that 19 SAS statements are executed one after another with the help of call execute. And now what I want to explain from whole of this is instead of using proc SQL into clause or call SYMPUT and then trying to run %do loop, That is, whenever we want to do dynamic programming, whenever I use the word dynamic programming in these particular cases is using dataset and achieving what we want to achieve without giving any manual input. So a data driven programs when we want to create, which again we can say in here as dynamic programming, we can use call execute, and call execute the code is much simpler. Now that we have looked into call execute, now let's look into what are the challenges which are posed by call execute. To understand the challenges, we need to run a different macro in here. Here I have a macro and this macro is test2. The striking or important factor or important thing about this macro is I have a data step in this macro, and also I have %put statement wherein I have a macro variable reference. So if I want to execute this macro with the help of call execute, here I need to be focusing on two things. The first one is the data step, which is a SAS statement. This does not run till this data step is completed. But the macro references and things which do not have SAS statements get executed immediately. So let us quickly compile this macro, and let me also quickly run this call execute. Here we see a warning. Before going into the warning, let me tell you one another thing, that is, this gets executed immediately, this gets executed later. That is after data step is complete. After this data step complete, only then this part of SAS statement runs. But this runs immediately as we have macro reference in here and there is no SAS statement in here. So because this has run immediately after I have ran this particular call execute wherein I am executing this macro, what will happen is this %macvar is a macro variable which is created in the step above, but this runs even before that. So we get a warning saying that this particular macro variable is not resolved, because if you see in here, this has executed immediately. That is, this part of our macro has been executed immediately. But if you see in here, our data step has run much later. So whenever you have macro reference without any SAS statement, it gets executed immediately. And anything related to SAS statements runs later. So here there is a timing issue. So you need to be very careful of that when you are trying to have macro references and SAS statements in a macro, and if you are executing through a call execute. Now there are ways to handle that and we will discuss that in a minute. Before going to do that, let me also quickly delete the macro variable which we have created in here. The problem with the call SYMPUT in this particular scenario is it creates a global macro variable, and this is a special case of global macro variables getting created in a macro. More on this topic I will discuss when I talk about scope of macro variables, which would be my next part of my macro series. And in here, let me delete the macro variable by saying %symdel and giving the macro variable name followed by semicolon. As we have created global macro variable in here, I am deleting it, and deletion of the macro variable is successful. So we no longer have our macro variable present in our session because we have deleted this global macro variable. One way to address this issue of timing is by simply using nrstr. So whenever you have macro references and you want to use along with the call execute, you always need to either use %nrstr, or there is another way to do it, but I will discuss that later. So what this %nrstr does is it delays the macro execution itself. So nothing get executed, unlike in here wherein it got executed in the data step itself, and then this got executed first because it did not had any SAS statement and it has a macro reference. In here it delays the macro execution itself. Now let us quickly run this. In here you can see that nothing has happened up before the data step is completed, but after the data step the macro gets executed, and everything gets executed in the order it was there in the macro. First this gets executed, then this gets executed. That is what we can see in the log also in here. I've also used mprint, and it shows the SAS statement was generated first, and then the another percent put statement which was there with the macro reference was done next. That is in the order it was available in this macro itself. So NRSTR helps with timing issue. Another one which helps us with the timing issue is do subl. Do subl is a new function wherein it has properties of call execute, and also it addresses the macro reference timing issues. For this, the code is pretty simple. Instead of call execute, I am saying in here rc equal to do subl, and then I am giving exactly the same what I have in here, and then closing with the parenthesis. One important thing to remember here is, here I have mentioned rc equal to, and then I am using do subl, and whatever I want to have in here I am putting in the parenthesis in here. The important thing to remember here is this rc could be anything. This is a simple assignment statement. And now let us quickly run this. Before doing that, let us delete the macro variable by using %symdel macvar, and this deletes our macro variable macvar. And after that, let's quickly run our data step which has do subl. Once I run this, here first I see that our data step runs first, and then our macro reference works next. What do I mean by that is it exactly runs the way the code is set up in my macro. So there is no timing issue with do subl also. So to sum it up, whenever we have macro references along with SAS statements, we need to be careful. We need to either use %nrstr or do subl to address the timing issues. That's all for this topic. Today's topic is about SAS Macro Series Part 10, and in this we are going to discuss about scope of macro variables. This is the last part in SAS Macro Series, and I also believe that this is one topic which each macro programmer should understand in detail. If this concept is not understood in detail, then there could be some problems. What are those problems and other things we will discuss very quickly. And now let us quickly talk about some theory. First, let's talk about local and global scope of macro variables. And in here, I have used the word generally. Means whatever I am going to discuss, this is accurate or correct to more than 90% of the times, but 10% of the time this is not exactly right. And what are those scenarios we will discuss. But first let's look into some theory. Macro variables created inside macro has local scope and they belong to local symbol table. And macro variables created outside macro has global scope and belong to global symbol table. Now, macro variables are stored in symbol table and these symbol tables are nested. Local is nested in global. Now we have covered enough of this theory. Now let us look into some description of this and some examples. Now this is the symbol tables which I was talking about, wherein the macro variables are stored in global or local symbol table. And if you see the global symbol table, local symbol table is nested in local, and all the macro variables created in global is also available in local, but whatever are available in local are not available in global. That means macro variable which we create outside of the macro are available outside of the macro, and also they are available to that particular macro. Whenever I use local, it means that particular macro in which macro variables are created. Now let us move forward and try to understand this better with simple example. In here I am creating a macro variable and I am saying %let a equal to my test. And in here I have a macro also, and in here I am creating macro variable and I am saying %let b equal to your test, and I am also doing a %put for macro variable a and also for macro variable b, and I am writing %ment. And this macro explain I am executing. Once I execute, I can see the value of a my test and also the value of macro variable b your test. So this explains us that the macro variable which I have created outside of the macro I can use in here, and I can also use the same macro variable which I have created in the same macro. This is nothing special. Now let us try to do %put ampersand a and ampersand b outside of the macro, and let's try to run this piece of code. And once we run this, we get one warning. It says that apparent symbolic reference be not resolved, which means the macro variable which we have created in this particular macro is not available outside. Now let's conclude this slide by 2 points. The first point is, whenever we create a macro variable outside of the macro, what it does is it creates a macro variable in global symbol table and it is available everywhere, and it persists or it stays throughout the SAS session. But whenever we create a macro variable inside a macro, what happens is it goes into local symbol table and it is available only to this macro, and also it persists only when we execute this macro. Now if you want to access this macro variable outside of the macro, to do that also is simple. All we need to do is we need to use a %global statement followed by the macro variable which we want to make it as a global macro variable so that it is available outside of the macro also. Now once we run this %let statement followed by compiling this macro and then executing this macro, and if we do a %put ampersand a and ampersand b, And if we run this %put also, we can access both these macro variables, and you can see from the results which I have pasted in here. By doing a %global followed by the macro variable name in a macro, I can access this macro variable anywhere, which means pretty much it's a global macro variable. Now that we have looked into %global, now let us look into a different aspect which is very interesting. Now in here I have %let a equal to my test, and in here I have a macro wherein I am creating a macro variable and I am saying %let a equal to your test. So here the problem is we have two macro variables with the same name, and scope of this macro variable is global, whereas the scope of this macro variable is local. Whenever you have two macro variables with the same name, there is a problem. Now let us try to understand that problem. First, when we run this %let statement, and it creates a macro variable which will have the value of my test. Now, once we compile this macro and once we execute this macro, what will happen is this local macro variable value, what it will do is it will override this macro variable name, and this value will become your test. Now let us quickly go 3 to 4 slides back, and we are here. And in here we have a macro variable a and its value is my test. And once we compile the macro explain and then execute this macro explain, what will happen is here also we are creating macro variable a. What it does in here is it always looks into a level up. In this case it is global. So what will it do is this macro variable a, it has a value of your test, it will go ahead and update this value also. So this is a problem. And if you see in here, when we execute this particular %put statement, you can see that the value of macro variable here is your test. Means this value has overwritten this value because we can access only a global macro variable outside, and this is a local macro variable, and this has overwritten this. And this is a serious problem, especially when you are trying to build a lot of macro variables inside and outside of the macro. The conflict between the macro variables is real and it's problematic. Now how can you avoid this so that this macro variable will not go and update this value? This can be easily done with the help of %local. So whenever you create a macro variable in a macro, if you write a %local and mention that macro name, what it will not do is it will not look into this global space and it just get restricted to this, and it doesn't care whether the same name macro variable is here. So the way to avoid the conflict when you have the same macro variable is by using %local and the macro variable name in here, so that now we are kind of protecting our global macro variable. Now once I run this %let statement followed by my compilation of macro and execution of macro, and then I do a %put %a, the macro variable value will be my test. So this value is kind of protected from this local macro variable by simply writing %local and the macro variable name. So more than often SAS macro programmers don't use this %local very much. but it's a very good practice to use %local whenever you can think of there could be a conflict and there can be a chance of overwriting global macro variable. Now let us look into another factor related to local macro variables. In here, to understand this, let's look into an example. In here, I have %let t equal to hello, means I'm creating a global macro variable in here, followed by a macro in here, and here I'm naming that macro as one more, and in here I'm using a macro parameter, and this is a keyword parameter. And in here we are also creating a macro variable t, and then when we execute it with a particular value, we are giving it a value in here. In here I am passing a value high, and once we run this %let and then we compile this macro and then we execute this macro by passing a parameter, we are creating a macro variable, a local macro variable. This local macro variable will never look into global symbol table. Unlike when we use a %let, %do or proc SQL into clause. So this is very important to know. I have not told anything about call SYMPUT or call SYMPUTX. It's even more little trickier, and we will have a separate topic on call SYMPUT. And then what will happen is when I do %put $t, we are accessing this macro variable, and we can see in here once we execute we have the value of hello. So this macro variable, which has the same name, doesn't override this macro variable. As I said to you, macro parameters only look for local symbol tables. They do not try to update global symbol table. Now that we have looked into this aspect, now let us get a little bit deeper. Now let us discuss about overwriting of macro variables when we nest macros. To understand this concept, let's look into an example in here. In here, I have two macros. The first one is test2 macro, in which I am creating a macro variable g, and it has a value of y. And also I am doing a %put and saying $g of macro test2. And in here I have another macro, and this macro is test, and in here I have a %let statement. In here I am giving the value of z to this g, and also I am executing this particular macro, and also I have a %put $g of macro test, means I just want to access this macro variable in here, and I'm closing this macro with the %ment. And when I execute this %test, what will happen is first this macro variable g, which belongs to test, will get created, and then this %test2 gets executed, and this test2 has another macro variable g, which has a value of y. And what these particular test2 macro variables will do is, as it is nested, it will overwrite the above macro variable or the above level macro variable, which has the value of z. And when I do the %put $g of macro test, as we have created the value of macro variable z with y, it overwrites the macro variable a level up, and then both of them will have same value. It is the same thing what we have seen earlier. It is overwriting of macro variables to the level up. Now let us try to understand this pictorially. In here I have a symbol table, and in this symbol table this is a global symbol table, and test2 is nested within this test macro. If you see in here, we have test and test2 is nested within this test. And in here, our test2 has the value of y. So what it will do is, even though we have created macro variable with value of z, this value of y also looks into this and it will update it. So again the same problem of overwriting. Earlier what we were looking was, we were looking into a local macro variable and we were looking into a global macro variable and overwriting of local macro variable to the global macro variable. Here what is happening is, a nested value updates the higher level local macro variable. Now I do not want to go too much into nested macros. I have never written a nested macro myself and I just wanted to tell or give this information out. So how do we avoid this? It's the same way. We are going to do a percent global and then we are going to mention the macro variable here, and then once we nest it, it will stay local to this one only, that is to test2. It doesn't overwrite, and once we execute this percent test, in the log you can see the result as in here. You see in here the value of test2 is y, whereas the value of macro test is z. So nothing has been overwritten. So this is an important point to remember, whereas in here it was overwritten. Now by this you could understand the importance of percent global and percent local. Now to explain about scope of the macro variables, we also need to discuss about call SYMPUT. Call SYMPUT and call SYMPUTX are little different. Now let us look into the first category where I want to discuss about macro variables created by call SYMPUT or call SYMPUTX in a macro. In here if you see, I don't have any parameter. Whenever we do not have any parameter and we use call SYMPUT, we are going to create macro variables in global symbol table. The reason for this is, whenever we use call SYMPUT or call SYMPUTX, it cannot create a local symbol table on its own. It has to be created first for this particular macro. To do that, we can have a parameter. If we do not have parameter, call SYMPUT and call SYMPUTX will create these macro variables in a global symbol table. And once I run this particular macro, or I compile this macro and execute this macro, I can access these macro variables outside of the macro by simply using %put and using the macro variable names here. And you can see I can access these macro variable values. I have made a very detailed video about call SYMPUT and call SYMPUTX, and link for the same I will give in the description below, and I would not like to talk about call SYMPUT and call SYMPUTX in here. I just want to talk about the scope. And in here another important point to remember is, whenever we use a %let statement, a %do loop or proc SQL into clause, even without parameter, they create local macro variables. Only call SYMPUT or call SYMPUTX is little different, and it creates global macro variables even in a macro. And this is an important point to remember. If it creates global macro variables, how we can make them local macro variables? You know, that is very simple. All you need to do is you need to use a %local. We have discussed about %local before. Now I would like to show you something different in here. Call SYMPUTX allows one more argument. That is, it can have three arguments. The first argument is a macro variable name, second argument is macro variable value, and third argument is scope of the macro variable. As I said to you, in here the macro variable is going to be created is a global, but I set the scope to be local. And another way is simply using a %local and mentioning this macro variable name. But here we are doing it through third argument, and we are saying L in here means local. Now if we try to access this macro variable outside of the macro, we will get a warning saying that this particular macro variable is not there. That is because it is now a local macro variable and it cannot be accessed outside of macro. Now we have looked into this aspect. Now let's try to look something different in here. Actually, this is something very similar to other macro variables which we have created in macro. Here we have very similar kind of macro, but in here we have a parameter. It does not matter what parameter this could be. If this macro has a parameter, and this parameter will create a local symbol table, and this local symbol table, what it will do is it will help these particular two macro variables to go into local symbol table. So now what will happen is, now when we pass the value of the macro variable in here, that is var equal to hello world, these two macro variables also go into local symbol table along with var. And when we try to access them outside of the macro, it will fail because these two macro variables are now of local scope. To make these macro variables global, it is again simple. In call SYMPUTX, we can give an additional parameter and we can say G. This creates a global macro variables. And another way to do is simply writing %global and writing the macro variable name. So to reiterate the whole thing, I just want to tell in one line. Whenever you do not have any parameter, call SYMPUTX or call SYMPUT will create global macro variables. Whenever you have a parameter, it is going to create a local macro variable. And the reason for that I have already discussed, that is call SYMPUT and call SYMPUTX on itself cannot create local symbol table for that particular macro. So it needs the help from parameter. And one last thing I would like to say is the third argument option is only available for call SYMPUTX, not for call SYMPUT. And also whenever we use call SYMPUT and we want to change the scope, all we need to do is we need to use %local or %global as we require. That's all for this topic. Now that you have watched 6 hours of SAS macro video, I have a couple of advice for you. The first one is to become better at anything, you need to practice a lot. SAS macro is no different. Please keep trying to solve a lot of SAS macro related problems. In my SAS macro playlist, I have a lot of problems related to SAS macro. Please check them out. And also I have some videos on about how to design SAS macros. And also I would suggest Art Carpenter's macro book, which is pretty good and very helpful if you really want to go deep in SAS macro and want to learn more. That's all for this whole of this video, and thank you so much for watching.